वंदन, अभिनंदन और नमस्कार। हर वर्ष करते हैं हम विज्ञान दिवस का इंतजार। देश के भविष्य और देश की जनता को दिखाएंगे हम आज विज्ञान के चमत्कार। Good morning to all of you. I am Reena from Chemistry Department presenting here the wonderful event National Science Day on the behalf of IIT Indore. हार्दिक स्वागत है आप सबका आज के कार्यक्रम नेशनल साइंस डे। बाय द वे, द साइंस इज सेटल्ड इन आवर लाइफ, सो एवरी डे वी मीट विद साइंस, बट टू मेक द वर्ल्ड ऑफ साइंस इवन मोर स्पेशल, टुडे वी ऑल हैव गैदर्ड हियर virtually to celebrate this beautiful day.
Nothing in life is to be feared. It is only to be understood. Now it is the time to understand more so that we may fear less. This is the famous quote from Marie Curie, and today it is the National Science Day. It is celebrated every year to commemorate the discovery of the Raman effect, which led Sir C.V. Raman to win the Nobel. This is the Vidhi Agrawal, and I would like to welcome our chief guest, Professor Nilesh Kumar Jain, Director IIT Indore. Guest of honor, Professor Avinash Sonavani, Dean International Affairs and Outreach IIT Indore, Professor Anurag Sharma from IIT Delhi, and our respected professors, all school teachers, students, and people whoever are present in this late.
धरती के कण कण से आसमां के चांद तारों तक, जीवों की संरचना से कल्पनाओं और परिकल्पनाओं तक, वेग संवेग क्रिया प्रतिक्रिया रसायनों की अभिक्रिया तक, शुरू से अंत तक बस ज्ञान विज्ञान ही तो समाया है। आज के समारोह में आए हुए सभी बच्चों का हार्दिक स्वागत। आज का प्रोग्राम मुख्य रूप से आपके लिए बनाया गया। आज हम आपको ले चलेंगे विज्ञान की सैर पर, जहां आपकी मुलाकात होगी ज्ञान विज्ञान की कई रोचक घटनाओं से। आइए आप और हम मिलकर इस दिवस को यादगार बनाते हैं। कार्यक्रम को आगे बढ़ाने से पूर्व मैं स्वागत करती हूं हमारे डायरेक्टर सर और समारोह के चीफ गेस्ट प्रोफेसर नीलेश कुमार जैन सर। सर, योर एवरी एक्शन रिफ्लेक्ट द लव ऑफ साइंस. Please come to inaugurate this most memorable event. Please welcome Professor Nilesh Kumar Jain sir.
Yeah. Am I audible?
Yes, sir, you are, sir.
Yes, sir. Yes, sir.
Okay. So, Professor Anurag Sharma, the eminent physicist from IIT Delhi, Professor Avinash Sonavane, our Dean of International Affairs and Outreach, and the organizing team of Science Day. So first of all, I would like to congratulate you, the entire team, the student volunteers, faculty members involved in it, because despite the pandemic time, you have organized it. This is a regular feature at IIT Indore, which we organize and invite the school students, particularly from 6th to 12th, and to expose them for the different aspects of science, physics, chemistry, mathematics, astronomy, and biology. So what it does, the purpose which we have started this, that how the young minds can be oriented towards the science, and as our beloved President Bharat Ratna Kalam, President Kalam used to say that you need to ignite the young minds, and this is the purpose of this event is that only, how can we ignite the young minds, because they are our future. And once Gyan Vigyan, we say that, so knowledge and science. So science has a lot of knowledge, but every knowledge is not science. That we have to understand. So the entire purpose was that what you know may not be scientific. That's why when the young minds come and to understand how the simple way the science can be understood, with the help of mathematical models or this, Otherwise, for some people, it may become a what we call as a burden. So science is to be enjoyed, and that was the whole purpose of organizing National Science Day. But because of this pandemic, we could not invite. Otherwise, if you see the past pictures, there used to be a huge crowd at our school building, and the student used to have a fun with seeing the different models, visiting the physics, chemistry, and biology lab, and then mathematical models. They used to enjoy that, and also see the cosmos, astronomy, the thing which everybody gets fascinated how the things work. And whenever we hear in the news or in the news article, they are not in the simple terms. So the entire idea is that how can we learn the science with fun? So I think the teams must be congratulated, led by Dr. Deepak Kumar Roy, where they have not broken this series. Otherwise, it would have been easy. Oh, no, this is pandemic time. Let us not organize it and all that thing. But despite that, because we have a lot of kids in our campus itself, everybody was asking, my son was asking, why it is not physical this time. We used to enjoy, go there and then see the things, how the things work. So it shows the even the second standard or third standard kids are enjoying it. That shows that how this program has been successful, and we are really privileged to have Professor Anurag Sharma, and he's going to talk about the optics. We know in daily life, everybody is wearing, those who are wearing the specs, they know the optics is there. So that is the simplest thing. So in the IT system, a lot of people wear these specs. So in our daily life, it is full of optics. So I'm happy to start this event, and I hope that it will be great success. All our kids at home, those who are school children, YouTube or through our IIT Live website, they will enjoy it. They will not miss the fun. And obviously today is Sunday, so people would have, yes, some exams are going on, but still, I request all the children who are there online or offline to enjoy the event. So with this word, I wish all the success to this, and also I compliment the efforts taken by our team to organize it in the hybrid mode, some online and some offline. Thank you very much.
Thank you so much, sir, for your valuable work. Now I would like to welcome our guest of honor, Mr. Avinash Tanavani, Dean of International Affairs and Outreach Director. Please, sir, take some glimpse of your scientific life that could pave a way for us to do better in our life. Please welcome Mr. Avinash Tanavani.
Thank you very much. First of all, I would like to thank Professor Anurag Sharma, our director, Professor Dinesh Kumar Jain, all the students from different schools, faculties, school teachers for joining this event. First of all, I would like to thank and congratulate the entire National Science Organizing team, which is led by Professor Dr. Deepak Roy, in taking this initiative and for putting a lot of efforts in the celebration of National Science Day at IIT Indore. So thank you all for this. Of course, this would not have been possible without the support of our director, Professor Nilesh Kumar Jain. On behalf of the entire organizing team, I would like to thank Professor Jain for extending a generous support for organizing this event. Today, I'm happy to see that the students from various schools and other parts of Madhya Pradesh are going to join this event today with us to celebrate the National Science Day at IIT Indore. So, as mentioned by Professor Jain, that National Science Day is celebrated across India on this particular day to mark the discovery of Raman effect by our great physicist, Sir C.V. Raman, in the year 1928. So I hope from various schools who are attending this event are aware about the Raman effect. So it talks about the scattering of light when it passes through the different materials. So it means when this light passes through different materials, it changes its wavelength. And for this discovery, Sir C.V. Raman, he has received Nobel Prize in Physics in 1930. the school children, I mean, you may probably know that Sir C.V. Raman is the only person from India who has received a Nobel Prize in Science. Of course, there are many other Nobel laureate winners like Rabindranath Tagore, Mother Teresa, Kaila Satyarthi, who is from the Madhya Pradesh, who has received a Nobel Prize in Literature, Peace, and so on. While there are other Nobel laureates like Hargobind Sharma, Venki Ramakrishnan, Abhijit Banerjee, who has received Nobel Prize in Science, but they are of Indian origin, but they have done their discoveries when they were working in other countries. So as you know, the main objective of this National Science Days is to bring awareness among the people, in particularly within the young minds, about the contribution of science in our daily life and to popularize the importance of science in the society. And I think it is the responsibility of all of us to honor the great contribution made by Sir C.V. Raman for his invention and his contribution in science. So on such platform, I think we need to discuss the issues in today's science, implement some innovative ideas to address the challenges which we are facing in day-to-day life. And you know that we all are going through a very tough situation due to the COVID pandemic. So to meet the challenges put by global this pandemic, I think we all need to come together to discuss, to find the solutions for these unprecedented challenges. And I think if we succeed to do that, then it will be a true celebration of the National Science Day. So I'm very happy to share that during even the COVID pandemic situation, IIT Indore is proactively making its contribution in the welfare of science and society. As you may know that during COVID, this pandemic situation, the entire IIT scientific community as well as students, they have made contribution in various ways, like by developing disinfectants, masks, by sharing our equipments to the colleges for diagnosis purpose, and also sharing our expertise for the disease. So even today, as you can see the program, which will be followed by this inaugural session, that the students and faculty from various departments of IIT Indore has made several models, which will be shown to the school children. Unfortunately, COVID situation, we could not arrange the visit of these young minds of students from various schools to our campus. But I thank all the students and faculties of IIT Indore for their putting this marvelous effort in organizing this event. Last but not the least, today we are extremely honored to have Professor Anurag Sharma with us. He is a great physicist from IIT Delhi. Thank you, Professor Sharma, for accepting our invitation and for spending time with our students today. So after this session, Professor Sharma is going to talk about optics around us, and I hope your interaction with the students will ignite their mind. So finally, I would like to thank the National Science Organizing Team for giving me opportunity to say a few words and share my thoughts with all of you. Once again, thank you all and wish you great success. Thanks.
धन्यवाद सर। धन्यवाद सर। हम सब अलग अलग तरीके से विज्ञान से जुड़े हैं। हमारी हमेशा कोशिश रहेगी कि वैज्ञानिक सोच का दायरा बढ़ता ही जाए। समारोह के उत्साहपूर्ण उद्घाटन के लिए आपका बहुत बहुत धन्यवाद। आज के कार्यक्रम का उत्साहित शुभारंभ देखकर हमें पूरा विश्वास हो गया है कि आज का दिन यादगार बनने वाला है। आज हम आपके साथ साझा करेंगे विज्ञान से जुड़ी कुछ कौतूहल भरी घटनाएं, जो आपको रोमांचक तो लगेगी ही, साथ ही आप जान सकेंगे विज्ञान से जुड़े कुछ तथ्यों को। तरंग, कणों और किरणों का खेल, प्रकाशिकी है विज्ञान का अद्भुत मेल। कहीं परावर्तन, कहीं अपवर्तन, गजब के खेल हैं जिसके, रोमांचक घटनाएं और विचारणीय प्रयोग हैं इसके। आप जान ही गए होंगे कि हम बात कर रहे हैं प्रकाशिकी अर्थात ऑप्टिक्स की। कार्यक्रम को आगे बढ़ाते हुए मैं स्वागत करती हूँ FNA, FASC, FNAC एंड SSB अवार्ड से सुशोभित प्रोफेसर अनुराग शर्मा सर का। आपने फिजिक्स के क्षेत्र में अपना अमूल्य योगदान दिया है। आप लेकर आए हैं प्रकाशिकी से जुड़ी कुछ दैनिक घटनाएं। Please welcome Professor Anurag Sharma sir for optics around us. Please welcome.
Okay, good morning, Suprabhat. I'm very happy to be speaking to you all. First of all, I would like to congratulate and compliment IIT Indore, led by the director and the dean, and of course, Dr. Deepak Roy, to have organized this event in spite of the difficult times that we are going through. And of course, the technology has come to our help. We are taking classes and everything we are doing through the internet these days, and so this event is also virtual in that sense. Although I can see that some people are there in the hall who are physically present. As you all know, it was mentioned earlier, this day is being celebrated in the to celebrate the Raman effect discovery on 28th February, I think in 1928, and and Raman effect, as the dean described, is about optical scattering. So it is apt that we talk about optics on this particular day, not every time, but at least once today. So I'm going to talk about optics and photonics that is around us, how we are seeing it and still ignoring it, or not knowing what is going on. And this is my topic today, and we'll talk about some very simple things. The director has already put the cat out of the bag when he talks about specs, because I'm going to start with that. So let me share my desktop. Where is the share here? Okay, share the desktop. So I hope you can see the slides.
Yes, sir. Yes.
Okay, fine.
Yes, yes.
So my title that you all know is Photonics Around Us. Photonics includes optics, of course. So let me first put you this mosaic of pictures. From the left, we have Twain and Tagore for the literature persons. Then we have a lot of politicians. And then on the right side, we have scientists from India and abroad, freedom fighters, of course, led by venerated Mahatma Gandhi. But what is common in all these? They are all wearing specs. You can see each one is wearing a spec. And so the specs have been around. You cannot go around after a particular age. You have to use the specs to be able to do what you want to do. Of course, the most famous pair of spectacles is that of Mahatma Gandhi. We have seen it many times, and these are, spectacles are invaluable vision aid. If you look at the statistics, approximately 75% of adults in the world actually need some sort of vision correction, and about 64% wear glasses, and about 11% wear contact lenses along with glasses or otherwise. If we come to the country, 35% of the population, which is about 45 crore people, are in the need of vision correction, which may be done by spectacles or contact lenses. However, only 25% of these, that means only 10 crore, actually have access to vision aid. So, there are a lot of work that can be done in this area. So eyeglasses are the simplest optical instrument that have been serving the humanity very widely for centuries. In fact, the first instance in a painting where the eyeglass is seen is in the 13th century. So before that, lenses were around, but not in the form of spectacles. So this is an example of optics and photonics around us. If we look at the COVID times, as was mentioned, that we have actually going through the COVID times, and one of the very common thing that you see whenever you try to enter a building, your temperature is taken by a device like the one which is shown here. And this is also an optical device. This is the infrared thermometer. So infrared rays come out from here and go to your forehead and return, and of course record the temperature. So this is also a device which has been all around because of the COVID. Another device because of the COVID which has been all around is oxygenation or oximeter, which measures pulse rate and oxygen saturation in the blood, is also an optical device. If you open the device, you will see something like this, which is a laser. So there are at least two lasers in this, which measure their, through the finger, they measure the transmission, and from there they infer what is the status of your blood. So these are the two very common devices which are today all around us. But I don't know how many of you really realize that these are actually the critical component is an optical component. The other thing which is very, very common in everybody's hands is a mobile phone these days. And typically mobile phones look like this, whether it is an iPhone or any other phone, they all look like this, very sleek looking, a very nice thing to hold in the hand, very soft, I mean, not really soft, but very smooth. So this particular device has a lot of optical photonics in it. So of course we have the two cameras. Mobile these days is not used so much for communication as it is used for taking photo. The cameras have vanished. The independent cameras have vanished from the society. All that you have is a mobile, which includes camera. So camera is the most important device. Then we also have a flash torch or lamp, which is very, very useful. Then you have the internet through which we communicate, is also an optical device we'll talk about. Then the LCD display that you have is an optical device. And then, of course, the manufacturing of this has a lot of laser in it. And so other things are a little obvious, but let's talk about the laser-enabled smartphone manufacturing. And this was an article written in 2012. And I'll just read the abstract of this, that today's smartphones pack enormous processing horsepower together with sophisticated touch screen displays in a compact rugged package. Laser processing plays a critical role in fabricating nearly every significant component of these products. Indeed, lasers can be said to be the key enabling technology in attaining the high level of functional sophistication, miniaturization, and durability achieved in these devices. For example, the PCB fabrication, which is the electronic circuit inside this, PCB drilling, you have very, very small drills to connect across this, which can only be done through laser. Display glass cutting, you may find why this is so important. The mobile phones are so rugged that if they have a fall, you don't easily break the glass. And the key thing is that when you cut the glass to a particular size, it is not being done through a mechanical shear cutting, but by a laser cutting. The advantage of that is that you don't actually produce micro cracks in the glass, which eventually lead to the cracking or a breaking of glass. And because of the laser cutting, this is absolutely, there's no micro cracks which are there. And so there's a very longevity and sturdiness. Touchscreen patterning and of course displays, these are all through laser. So at home or in the office, if you see what is the optics around, LCD display of computers and TVs, remote of TV or ACs are all infrared pointers. Laser printers, of course, uses lasers, and scanners have imaging devices, cameras, and so on. CDs readers and writers use lasers, laser pointers, which are very common these days. And of course, desktop and laptop have your cameras, through which, like I am also speaking to you through a camera, this video is going to you. So these are all optical devices which are around us. If you go to a mall, I'm sure you have been to the various malls these days. So important things which are there, PC, camera, and TV, which is for security and monitoring of goods, because there's so much input of and output of people that the security is very important. Even in optical, in public places these days, on the streets, everywhere, people are putting now CCTV, cameras for CCTV monitoring. Laser bar scanners were actually a game changer in shopping or in creating malls, because with this you can very quickly sell the items and put their price, and everything comes on the display. Lighting of displays and other spaces is extremely important because how you present your goods is how you sell your goods. And LEDs have opened an entirely new dimension with the lighting, with the what you can say, decorative lighting and otherwise. Holographic stickers, which you find on various devices for protection from fake goods or copying, is everywhere. These are also produced optically, and these are nearly impossible to duplicate. 3D scanning and projection is another very big area. 3D laser scanning, through that it is possible to collect data about an object, because you can actually scan throughout in the 3 dimensions without touching or without destroying the object. The collected data can be used to make a 3D model. These 3D models can be used to redesign or reverse engineer the object. The 3D created objects or data can also be used to create a 3D projections by laser spot scanning mediated by some scatterer. These are strictly not holograms, although holographic adjective is used. You say holographic display, but they are not holographic. These on the stage that people see and so on. And these are commonly called holographic, but these are actually lasers fly spot scanning mediated by some scatters like smoke or screen or something like that. Lighting of interiors and public places, LEDs have completely changed the view. LEDs are inexpensive, efficient, flexible devices of lighting. The power consumption is extremely low. I'll talk about that a little later. They are now available in all colors, so you can actually do a lot of decoration. If you see the what is the advantage of LED, this particular picture will show you. If you see the normal lamp, which was in the 19th century invention of Thomas Edison, had only 16 lumens per watt. Lumens is the capacity, how much illumination you can do, and watt is the power that you are trying to consume. And it could actually last only about 1,000 hours. Then came in the 20th century fluorescent tube, which we all use in our homes till now, and probably still using. It's 70 lumens per watt. So it was about 5 times or 4 times better. And it also has a 10,000 hours of life. But if you come to the latest invention, which is an LED, you have 300 lumens per watt. Okay. So from here to here, it is again 5 times, so 4.5 times. So what we could do achieve in 100 watts, actually can achieve in 10 watts or 12 watts or something like that. I mean, normal LED bulbs are 9 watts, 6 watts as compared to the 100 watt or 500 watt bulbs that we had earlier. And LED also has a very, very long life, 10,000 hours. So really, it has completely changed the illumination, how you illuminate your spaces. Lighting represents almost 20% of global electricity consumption. This is the data from the International Energy Agency. The future development of society in both developed countries and emerging economies around the world are intimately tied up with the ability to effectively light our cities, homes, schools, and recreation. If you don't have enough light, your work efficiency goes down. So the power consumption in LED is extremely low. And so this is actually changing the requirement of electricity. Electricity can be used for other purposes. Another very important thing is that the LEDs is just actually an inverse process of solar cells. So they match very perfectly well. So if you have a solar cell with a small battery and attach LED to this becomes a very independent solar lantern, and these are used extensively in rural areas, but also in the cities. You see these hawkers and telewalas these days are using these LED lamps, which can be charged either through electricity or through solar, and these are really ideal solutions to provide light in isolated area. You don't need a wire or anything; it's just an independent unit, and this is how even a very remote village actually now can have light without wires going across from the cities or the powerhouses. So you can see all kind of decorative lighting because of LED. You can also have agricultural lighting because you can combine different colors and choose the spectrum that you want to expose the plants to. and of course indoor lighting and displays, all swimming pools, everything is being done through LEDs now, and the power consumption is extremely low. It is actually safe because it's a low wattage, a low voltage thing. uh, this is what we have at IT Delhi. All the streets and everything is now LED lighting. So it's really has changed the we look at spaces and illuminate spaces. So light has been at work. I mean, these examples show that how optics and photonics are playing an increasingly important role in the society. However, this is not something that is happening today. Light has been providing solutions for many, many years. Lasers, which were invented in 1960, accelerated the pace of development in many folds. And we celebrated last year 60 years of laser. It was 1960 to 2020. So if I look at really astronomy, the director talked about astronomy being a very fascinating subject. But can you think of astronomy without a telescope? The first time the astronomy, who is the father of astronomy is Galileo. Why? Because he actually made the first telescope, and he could see the craters on the moon. He could see the rings of the Saturn. Many things he could see for the first time in the history of mankind. So it was all because of the telescope, which is an optical instrument. Similarly, in medical science or a biology lab, can you think of a biology or medical science lab without a microscope? You have to have a microscope. That's a really on every table actually you need. So microscopes are also optical devices, as we know. Similarly, if you are doing chemistry or material science or any other physics, spectroscopy is extremely important. I mean, what Raman discovered is also part of spectroscopy. So Raman spectroscopy is really a very, very important tool these days to understand molecules, to infer what the properties the molecules have. So the optical technology has been enabling technology for centuries, and it continues to do so. So light is really what is enabling everything. In fact, light is the source of life on Earth. All forms of energy except the nuclear energy is coming from the sun, which is through light. Optics is the science of light. Photonics was a new word coined to include technology. So it's the science and technology of light is what we call photonics. And photonics revolution is what we are witnessing today, ever since the birth of lasers and then fibers later on, really, and LEDs. It's really a photonics revolution that is going on these days. And the world woke up to this particular fact that light is really important. So the International Year of Light and Light-Based Technologies was celebrated in 2015. And since 2018, we have been celebrating the International Day of Light on every May 16. May 16 was the day in 1960 when the first laser was made by Theodore Maiman. So photonics revolution is going on, as I said. So on the most fundamental level, through photosynthesis, as I said, light is necessary to the existence of life itself. And in many applications of light have revolutionized society through medicine, communication, entertainment, and culture. Light and photonics are poised to become the key enabling technologies of the future. This is what has been said by the UNESCO Committee on the International Year of Light. Several quotes I will come from there. All over the globe, people are using light to discover solutions for society's most pressing problems. For example, during COVID times, I gave you two examples. You imagine if you had to use a thermometer in the mouth or elsewhere to measure the temperature of every person who's trying to enter the building. What will happen to the to our throughput? But with this non-contact infrared thermometer, things are very fast, and there's no invasion of privacy or anything of anybody. No touch, non-contact. So from 3D printing to bringing energy solutions to developing regions, light is the key in driving economies and encouraging the development of the civilization. So if I see the science in Nobel Prizes in optics and related areas, there have been 18 Nobel Prizes in physics, 18 times I should say. There are 30 scientists involved. In physics, 14 since the invention of lasers. So it's before 1960, which was invention of laser. The first 60 years Nobel Prize, because the Nobel Prize started in 1901. First 60 years, we had 4 Nobel Prizes going to optics. And in the next 60 years after the lasers, there were 14 Nobel Prizes which have gone to optics. In the last few years, several have gone to optics and photonics. One in chemistry in 2014, and one in medicine long back. Okay, so even our only Nobel Prize in science to C.V. Raman was also in the same area of optics and photonics, because it was on nonlinear optical scattering. So there are many application areas, but just to focus on some: energy, as I talked about, lighting, solar cells, lasers, they are all energy providers. Health, in health science and medicine, imaging, sensing, therapy, phototherapy is an important thing. In communication, lasers and fibers are playing very important role, and enabling technology for imaging and sighting, and for defense applications. This is extremely important. So if you look at the energy, when we think of light and energy, there are 2 kinds of approaches that come to mind. One is here and now and has much more immediate potential, and the other is around the corner, awaiting further development. This later one, which is the awaiting around the corner, is the laser fusion. If the fusion comes through, all energy needs of the world will be taken care of, because then we'll be able to create our own small suns around. But that's still going on. It's not come to a level where it can be used. But the former, which is here and now, is of course the solar energy. And we have been using solar energy either for in the thermal form or in the optical form, which is the solar cells. And the in fact, the energy from the sun that reaches Earth can be converted into heat or electricity. And the governments and scientists worldwide are working to develop affordable, clean solar energy technologies. I'm sure at IIT Indore also some people are working on this. And solar energy will provide a practically inexhaustible resource that will enhance sustainability, reduce pollution, lower the cost of mitigating climate change. So this, these things are all connected. So solar cells are becoming cheaper and easily accessible to wider population. But optics played another role in solar cell. Limitations in efficiency of the solar cells are being reduced by the use of innovative photonic solutions. And these include availability of more radiation to the active layer, efficient use of solar spectrum, and also longer paths of radiation in the active layer, so that the more absorption can take place. So these are, again, solar cell itself is a kind of photonic device, but there are a lot of photonic activity is going on to increase the efficiency of the solar cell. And of course, organic materials are being used increasingly for these applications of solar cells. Then the lighting LED, as I said earlier, now with LED, the power consumption is much less, and hence energy saved is energy harvested. I mean, if you consume less, effectively you're producing more in some sense. So LEDs have revolutionized the lighting with efficient and low energy consumption. And this quote I have said earlier about 20% light, global electricity being used by lighting. Another form of energy is the high power lasers, and particularly the fiber lasers. So lasers have truly revolutionized science and technology, as I said earlier. High power lasers have a variety of applications in military and industry. In fact, the future military engagement are going to be laser based. The kind of things that we have seen probably in science fiction movies, something like that is going to be. Now you will have a laser beam which will destroy a tank or a plane or whatever. So these things are going on right now, and some of us involved with DRDO in these activities. The latest development in high fiber lasers are changing the face of manufacturing. In fact, most of the manufacturing, cutting of metal, cutting of other material is now being done by a laser. And earlier, a laser used to be very bulky, but with fiber lasers, as you can see here, it's just a piece of fiber which is being pumped through some other energy device, and this is the laser head. And this you can move very easily across the sample and create any pattern that you want. So in fact, car manufacturing it uses laser cutting very extensively. And that is how the finish is very, very smooth. In health and medicine, photonic technologies provide a new tool for doctors and surgeons. New developments in optometry and vision science improve quality of life. Light-based technologies are used every day in medical diagnostics in ways that we often are unaware of. Breakthroughs in light technologies continue to revolutionize the medical industry, medical imaging, surgical procedures, even diagnosis rely upon light. In fact, I'm sure those who have gone through the vision testing, you have this OCT, which is optical coherence tomography, through which actually you can see the different layers of the retina, and you can actually figure out what is happening. And this has been possible because of the optical imaging technique called optical coherence tomography. So lasers are especially crucial in dermatology because on the skin, if you have any problem, you can actually, the advantage of a laser is it's a very focused tiny spot of high energy, so it can deliver to a sample, to your hand, or to anything, or to where you want a burst of energy which can actually do wonders. You can remove skin defects and so on. Even in dentistry and ophthalmology, of course, depends heavily on optical instruments. And dentistry also, they are looking at, because laser, as I said, it can be a very tiny spot, so it can actually sculpt can be used for sculpting your tooth and so on. In fact, lasers are now widely used for common procedures such as tumors, tattoos, hair and birthmark removal, eye surgery, and other surgical procedures, of course, have use. When you do cataract operation, you have to open the cornea, and these days laser, very small tiny hole is made, and through that it can be done, and it heals very, very fast. So these today cataract operations are actually a day. I mean, you go in the morning and by afternoon you're free. So this is all because of the lasers. More recently, light applications, specifically lasers, have been used in medical diagnosis due to their non-invasive properties. So actually, for cancer detection, for tissue oxygenation, which I showed earlier, early detection of tumors by fluorescent spectroscopy through lasers is something which can actually tell you what is going on in a particular tissue, and it's extremely useful. So light is crucial in exploring the fundamentals of life and our surrounding environment. The overarching fields of physical and natural sciences rely on photonics technology to explore and better understand our world. So this is not only in application, but also in science and technology and understanding the world. So the last thing that I want to talk about is the world of internet. So today I'm talking to you because of the internet. And the whole world is crisscrossed with optical interconnections. I mean, this is only a pictorial view. I mean, we don't have wires or fibers going like that. So social media, low-cost telephone calls, video conferencing with family and friends. These are three examples of how the internet allows people around the world to feel connected in a way that has never been possible in the history. And all this is because of the light. And this was the quote from, again, UNESCO committee. So what is internet? Internet is, of course, through the optical fibers. These are the optical fibers, as you can see. This is the strength member. These colored things are the optical fibers. And you have fiber optic connectors these days. These are all optical connectors. And lifeline of the internet is optical fiber. Everything is going through the optical fiber. So lifeline of the internet is the optical fiber, and what gives life to optical fiber is light, or to the internet is light. So what we are sending light, of course, it is invisible, it's infrared light, 1.55 micron, but it is still light. So the optical fibers are extremely thin, flexible, transparent fibers made of silica or plastic. These hair-like fiber transmit light signals from one end to the other end, and it can be kilometers, because you can join fibers almost seamlessly and go on for hundreds of kilometers. And so over long distances under the sea, you have cables these days from Europe to US. These are called transatlantic telecommunication cables. They have always been the state of the art, and today it's a fiber cable which is going through this. Most commonly used in telecommunication, the use of light in fiber optics has revolutionized the way humans interact in 21st century. In fact, because of this connectivity, you have all this social media, and all over the world, the governments are actually very wary of this social media because it's a totally new world. I mean, and they are not able to control it. So it's entirely new sociology that this connectivity has actually created. Sociology and governance become a problem. Unlike wire cables, fiber permit transmission over long distances with high bandwidths. The bandwidth is so high. Bandwidth means how many telephone calls you can send, how many gigabits or megabits of data you can send. That is the meaning of bandwidth, and it is so high these days. Actually, the mobile connectivity is virtually free. I mean, in 500 rupees you can talk the whole month, send as many pictures, as many videos that you like, and it is all nearly unlimited. So really, it has been possible because of this optical fiber. Also, because the loss is much less, metal wires were very absorbing and so on. So all those details I don't want to go. And also this is very important, they are unaffected by electromagnetic interference. So in fact, most of the users today will not even understand what it means, because you when you talk to somebody on telephone, the voice is so clear as if somebody is just standing in front of you, because of the digitization and because of non-interference of electromagnetic interference. What it means is, in all around you have so much electromagnetic radiation going through, and optical light being very, very high frequency is not affected by this radio waves or whatever waves that we are going on, which are around. So there's no interference and there is no noise, there is no breaking, there's no signal drop. Okay. If you look at the internet usage in the world, today, this is the data of 30th June 2020, 62% of the world population actually have access to internet. Okay, they are using in some way or the other, which is extremely high for any technology ever in the history of science, in the history of the world. No other technology has been so widely sort of penetrated into the entire world population. So if I look at the photonics technologies, it's as I said, enabling technology, because it has to combine with either electronics or mechanical or something to give you a full device. But it has a lot of application. It's a critical component for most of these applications. So in defense application, I said vision devices. It's extremely important. You would like to see the enemy targets, and so you need vision devices. You need detection devices. You want to know where the explosives are, where other things are. So you need detection devices. You need target annihilation. As I said earlier, lasers are being used to explode now various devices, buildings, tanks. So you can actually deliver kilowatts of energy through a laser beam, and then you can actually destroy the targets. In space applications, of course, the simplest thing is the camera and sensors. You need cameras. I mean, you're sending an emission to Moon or Mars. You need pictures. Those are your eyes there. So you need good cameras. You need good sensors for any space application. For industrial use, as I said, for cutting, for sensing, for control, and for lighting. In a workshop or at a factory, if your lighting is not proper, you will be prone to accidents and you may not work efficiently. So lighting is extremely important. Even in the operation theater, the light has to be such that there's no shadow from any part. So lighting is very, very important. For energy, of course, solar cells and LED lighting that I have talked about. For science and research, microscopy beyond diffraction. 2014 Nobel Prize to chemistry was actually for microscopy. Molecular manipulation, these days you can use lasers to actually move around the molecules the way you like. High power and pulse lasers of extreme intensities. This is something which is recent in the sense in the last few years. In fact, the Nobel Prize in 2018 was given to a technology which could use the technique which could actually produce high power pulses of very short duration. And this is something which is actually changing the way we understand and science, because you can have extremely high powers, 10 over 18, 10 over 19 watts, something like that, in a very short time, which can knock off the electrons from the orbit, and so you can actually see what is going on inside an atom. And this is like accelerators on the tabletop accelerators, which will be available soon, and in the lab people have already made, and many other applications that where the photonics is involved. So to summarize, the optics and photonics is enabling technology and can offer innovative solutions to many problems of society. But of course, you have to know how to use it. You have to understand its properties. Only then you can think of solutions. That is why it is important that we understand what is optics and photonics. It will always be integrated with another technology to provide full solution, but it will be a key technology. For example, in a laser CD writer, the laser is probably a very small part of the entire electronics that you have. But if the laser is not there, then the whole device is actually dead. It's the heart of the device. A higher level of awareness about light and its properties is needed to aid all this. If you want to use, any engineer or a scientist want to use optics or photonics for an innovative solution, then you have to know what it can do and what are the properties that it has. So it's important that we understand what is optics and what is optical technology. The Indian scenario, a very small R&D community. Probably I can count something like 2, 3, 4, 100 people on my fingers who are actually involved in this kind of work. General awareness is poor. In education, content is poor. Optics is not a subject at MSc level except in few institutions like IITs. Engineering curriculum almost has no photonics except the electrical engineering, where the communication is important. So you can't escape fiber communication. But otherwise, mechanical, civil engineers don't even know that what can be done. And in all these areas, optics and photonics and lasers are providing solutions to very critical problems. Hardly any training for the technician level. You can get an electronics technician, you can have mechanical technician, but to get an optics trained technician is extremely hard in this country. So this needs to change if we really want to take advantage of this optics or photonics revolution. Otherwise, we let this revolution also pass by, like many others have passed by us. Thank you. I rest my case.
Thank you so much, sir, for the wonderful presentation and making us aware with the concept optic around us. So it's pleasure to hear you. Any questions?
If there are any questions or anything, I would be happy to answer.
Thank you, sir, for this talk and making us aware about few things. Sir, can you please put some light, if I put it in correct perspective, the difference between the optical electronics and optoelectronics?
There's no difference. Optoelectronics, optical electronics, photonics, they are all synonymous.
Okay, thank you.
Any further questions? Thank you, sir. It's pleasure to hear. So till now, we saw the optics, how optics related to our life and surroundings. So let's move on to different branch of physics and see some fun experiments demonstrating the concept of it. So I like to welcome Professor Rajesh Kumar from Physics Department and Ms. Chanchal to conduct the session.
Okay. Before we proceed to the rest of the proceedings, it's my privilege to thank Professor Anurag Sharma and very clear about situation. attended his lectures during my MS, spent a good time, and I know what kind of inspiring personality he is. So thank you, sir. Thank you very much for this talk and your time. Thank you. Thank you very much.
My pleasure. I hope I made some sense. Yeah. Okay.
Yes, of course, sir, for students and for all of us. Thanks.
Thank you, sir. Let's move on to physics topic.
गुड मॉर्निंग एवरीवन, दिस इज चंचल फ्रॉम द डिपार्टमेंट ऑफ फिजिक्स। तो जैसा कि आज हम नेशनल साइंस डे के उपलक्ष्य में विज्ञान की कुछ रोचक बातें और कुछ एक्सपेरिमेंट्स आपको दिखाने वाले हैं, तो इसी श्रृंखला को आगे बढ़ाते हुए हम बात करेंगे भौतिक विज्ञान यानी फिजिक्स की। तो अब क्वेश्चन ये है कि भौतिक विज्ञान क्या है? क्या हम जानते हैं भौतिक विज्ञान को? भौतिक विज्ञान फिजिक्स बेसिकली साइंस की वो शाखा है जिसमें हम सामान्य तौर पर यूनिवर्स में हो रहे नेचुरल फिनोमिनास की बात करते हैं। ये कोई रॉकेट साइंस नहीं है, इट्स जस्ट कि हमारे आसपास हर कोई भौतिक विज्ञान से घिरा हुआ है, जैसे घरों में खाना बनाने में, लाइट्स का यूज करने में, और बहुत से हमने एक्सपेरिमेंट्स देखे हैं चुंबक को लेकर के, मैग्नेट्स से। तो उसी को आज हम डेमोन्स्ट्रेट करने वाले हैं हमारे फिजिक्स डिपार्टमेंट के प्रोफेसर डॉक्टर राजेश कुमार, जो कि चुंबक के कुछ रोचक एक्सपेरिमेंट्स आपको दिखाने वाले हैं। इसलिए मैं इनवाइट करना चाहूंगी प्रोफेसर डॉक्टर राजेश कुमार।
ओके, थैंक यू चंचल। उसने कहा कि फिजिक्स कोई रॉकेट साइंस नहीं है। रॉकेट साइंस में बहुत सारा फिजिक्स है और इसीलिए फिजिक्स को समझना जरूरी है। जैसे अभी अनुराग शर्मा सर ने भी बताया हमें कि हर फील्ड जो फिजिक्स से रिलेटेड जितनी भी हैं कितनी रोचक है और कितनी चीज़ों से हमें जोड़ती है, जिसके बिना कि कई सारी चीज़ें हम समझ भी नहीं पाते। तो इसी चीज़ से ये यहाँ पर तो MSc PhD के स्टूडेंट्स रहते हैं, उनके लिए तो बहुत ज़्यादा मज़ेदार नहीं लगेगा। मतलब जानते तो वो सब चीज़ें हैं, बट देखिए ऐसे ऐसे अगर आप यहाँ बच्चे बन के बैठेंगे तो आपको बहुत ज़्यादा अच्छा लगेगा सबको। तो थोड़ी देर के लिए हम लोग बच्चे बन जाते हैं। तो ये पहले से एक वीडियो हम लोगों ने बना के यहाँ पर रखा हुआ है, तो हम यहाँ पे एक वीडियो शेयर करते हैं आपके साथ। बिल्कुल। तो अभी तो अभी हम क्या देखेंगे, कुछ एक्सपेरिमेंट जो हमने किए अपने लैब में, तो उन चीज़ों को हम देखेंगे। ये वीडियो आप देख पा रहे हैं यहाँ पर। तो हम अपने लैब में हमने कुछ एक्सपेरिमेंट करे हैं। जो ये दोनों यहाँ हैं, ये तनुश्री है, ये सुचिता है। इन दोनों ने मिलके हम लोगों ने अपने लैब में, जिस लैब का नाम है मैड लैब, इसका पागलों से कोई लेना देना नहीं है, बस इसका नाम है मटेरियल्स एंड डिवाइस लैब। तो वहाँ पर हमने कुछ एक्सपेरिमेंट किए चुंबक से रिलेटेड। चुंबक से संबंधित चीज़ें हम सब जानते हैं। चुंबक क्या करता है? लोहे और लोहे जैसी चीज़ों को ये अपनी तरफ खींचता है। लोहा जब लोहे को या चुंबक जैसी किसी चीज़ को अपनी तरफ खींचता है या अपने से दूर की तरफ भी धकेलता है, निर्भर करता है कि वो किस तरह का चुंबक है। और जो ये चुंबक होता है, इसमें ये शक्तियाँ होती हैं पहले से, और उसको दिखाने के लिए इस तरह की एक लाइन के माध्यम से हम दिखाते हैं कि एक चुंबक होता है, उसमें इस तरह से नॉर्थ और साउथ पोल बने होते हैं, उत्तरी ध्रुव और दक्षिणी ध्रुव बने हुए होते हैं। और जो ये जहाँ पर ये N और S लिखा हुआ है, वहां पर देखो कैसे बहुत ज्यादा लाइन की डेंसिटी बहुत ज्यादा है, बहुत सारी लाइनें वहां से निकल रही हैं और यहाँ पर अंदर की तरफ जा रही हैं। का मतलब है कि वहां पर जो चुंबक है उसमें शक्ति उस जगह पर ज्यादा है, तो जहाँ वहां पर ज्यादा फोर्स लगेगा। तो इसी चीज को हम इस प्रयोग के माध्यम से करेंगे। ये हमारा असली चुंबक है। आप ये लाल और ये नीला देख पा रहे हैं, तो इसमें जो लाल हिस्सा है और जो नीला हिस्सा है ये उत्तर और दक्षिण दिखा रहा है, और ये जो है ये चुंबक का या लोहे का चूरा है। तो इस जब चूरे इस लोहे और चुंबक के चूरे को जब हम इस चुंबक के पास रखते हैं, तो यहाँ पर जिस तरह की इधर तस्वीर बनी हुई थी, यहाँ पर की लाइनें आ रही थी और निकल रही थी, और ऐसे ही यहाँ पर देखो बाईं तरफ की तस्वीर में ये नीले और लाल रंग का जो असल में चुंबक है, यहाँ पर क्या हो रहा है कि जो इस दोनों का सिरा है जहाँ पर ये रखा हुआ है, वहां पर ज्यादा ज्यादा ये चुंबक इकट्ठा हुआ है, जो लोहे का बुरादा जिसको मैं कह रहा था। और वो उसी तरह से है जिस तरह से कि ये असली जो चुंबक की लाइनें बनी हुई थी जो आपने किताबों में देखा होगा। तो हमने यहाँ पर क्या देखा कि जैसे किताबों में ये लकीरों लकीरों के माध्यम से दिखाते हैं कि कहाँ पर चुंबक में ताकत ज्यादा है, कहाँ पर कम है, उसी चीज को हमने यहाँ पर इसके माध्यम से भी देखा कि ये असल में ऐसा ही है जैसा हम किताबों में बनाते हैं। बहुत ही साधारण सा ये प्रयोग, साधारण सा दिखने जैसा प्रयोग है, बट इसमें कितने निहितार्थ हैं फिजिक्स और भौतिकी से रिलेटेड, ये आप देखो कि जो किताब में ऐसे ही बना के लाइनों से दिखा देते हैं, पर इस चीज को आप घर पर भी कर सकते हैं। ये बहुत ही साधारण सा काम है। आप एक चुंबक ले सकते हैं और थोड़े से लोहे के बुरादे, आपको ये कटर वाली मशीनों वाली दुकान में आपको मिल जाएगा, वहाँ से पूरा इकट्ठा कर सकते हैं। या फिर कोई एक चुंबक, जो आपका हेडफोन खराब हो गया हो, तो हेडफोन जो खराब हो जाता है, तो हेडफोन का जो जिसमें कि ईयरफोन होता है, वहां पर एक छोटा सा आपको काले रंग का चुंबक मिलेगा, आप उसको ले लीजिए, उसको पीस लीजिए, कूट लीजिए, तो वो चुंबक का पाउडर बन जाएगा। तो एक बड़ा चुंबक लीजिए, उस चुंबक के आसपास आप इस तरह से चुंबक के बुरादे को डाल देंगे, तो इस तरह से आप मैग्नेटिक लाइंस ऑफ फोर्स जिसको कहते हैं अंग्रेजी में, हिंदी में आप क्या कह सकते हैं, चुंबकीय बल की रेखाएं। तो चुंबकीय बल की रेखाओं के माध्यम से आप दिखा सकते हैं। अब हम थोड़ा सा इसको क्या करेंगे कि अलग अलग तरह से चुंबकों को रखेंगे और देखते हैं कि इसमें किस तरह से इस तरह की चुंबकीय रेखाएं बनती हैं। तो हमने ये दो चुंबक ऐसे लिए हैं जिस चुंबक में कि दोनों जो नॉर्थ पोल है, दोनों जो उत्तरी ध्रुव है उसके, वो एक तरफ को है। अब हम सब जानते हैं कि जो उत्तरी अगर सेम तरह का पोल हो, अगर उत्तरी ध्रुव को एक साथ रखें तो वो क्या करता है, एक दूसरे को धकेलता है, प्रतिकर्षित करता है, और अगर उल्टा रहे तो एक दूसरे को आकर्षित करता है। तो जब ये प्रतिकर्षित और आकर्षित कर रहा है, तो उस जगह पर चुंबकीय जो रेखाएं होंगी वो कैसी होंगी, उसको जरा सा समझने की कोशिश करते हैं। यही जो वापस से जो अपना लोहा चुंबक का बुरादा था वो हमने इकट्ठा कर लिया था। देखो यहाँ पर क्या हो रहा है कि ये जो दो चुंबक रखे हुए हैं समानांतर, इसके बीच में जो दोनों चुंबक के बीच का क्षेत्र है, उसमें कोई भी चुंबक आपको नहीं दिख रहा है कि आसपास कोई लाइन ऐसा बना रहा है। सिर्फ ये हो रहा है कि जो लाल और नीला हिस्सा है वहां पर वो सिर्फ चिपक गया था। तो इसका क्या मतलब हुआ कि जो एक दूसरे को जो प्रतिकर्षित कर रही है, एक दूसरे को जो धकेल रही है, तो वहां पर चुंबकीय की रेखाएं हैं ही नहीं, तो वहां पर कोई बल उस पर नहीं लग रहा है। अब इसी चीज को हम क्या करेंगे, एक बार हम इस दोनों चुंबक को एक दूसरे के उल्टे पोलैरिटी के साथ रखेंगे, जो दोनों के ध्रुव हैं उल्टी उल्टे ध्रुव, उनको एक साथ रखेंगे। तो क्या होगा कि जो उत्तरी ध्रुव दक्षिणी ध्रुव के साथ आ गया और दक्षिणी ध्रुव उत्तरी ध्रुव के साथ आ गया। उत्तरी और दक्षिणी ध्रुव यहाँ पे लाल और नीले रंग से आपको दिख रहा है। लाल और नीला रंग आमने सामने है, का मतलब है कि इन दोनों के बीच में आकर्षक बल लग रहा होगा, आकर्षण का बल लग रहा है। तो उसमें अब देखते हैं कि किस तरह का हमारे पास चुंबकीय रेखाएं बनेंगी। तो ये सेम सेम प्रयोग करना है, चुंबक को अलग अलग हिसाब से रखिए, आपको जैसे भी इच्छा हो, आड़ा तिरछा कैसे भी आप रखिए, तो ऐसा खेलते रह सकते हैं। अब देखो यहाँ पर क्या हुआ कि जो ये दोनों चुंबक की रेखाएं थी, अभी थोड़ी देर पहले जब हम इसी प्रयोग को कर रहे थे तो इसके बीच में कुछ भी रेखाएं नहीं बन रही थी, लेकिन अभी जब हम इस चीज को कर रहे हैं तो यहाँ पर क्या हो रहा है कि जो बीच में है, बीच में भी चुंबकीय बुरादा उस पर चिपक रहा था। तो इससे यही पता लग रहा है कि किस तरह से जो दो अलग अलग जो पोल होते हैं नॉर्थ और साउथ, तो आपस में आकर्षित करते हैं, बीच में कोई खाली जगह नहीं बचती। यहाँ पर बीच में सारी चीजें आ गई। अब ये जो चुंबक है ये कैसा था, ऐसे डंडी जैसा था, इसको कहते हैं बार चुंबक। अब इसी चुंबक को एक और दूसरे तरीके का चुंबक होता है जिसको कहते हैं नाल चुंबक। नाल चुंबक क्यों कहते हैं? अगर आपने घोड़ा देखा होगा, घोड़ा तो देखा होगा, घोड़े के पैर में ऐसा नाल लगाता है ताकि जैसे अपन हम लोग जूता पहनते हैं तो ऐसे ही घोड़े को भी ऐसा जूता पहनाते हैं लोहे का, ताकि वो टप 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 की आवाज आती है ना, इन दोनों गानों में भी रहती है, और ऐसे भी घोड़ा चलता है तो टप टप की आवाज आती है, तो वो इसी नाल की वजह से आती है। तो वो नाल जो है ये इसी इसी आकार का होता है, इसी शेप का, इसीलिए इसको हिंदी में कहा गया नाल चुंबक। और इंग्लिश में इसको हॉर्स मैग्नेट भी बोलते हैं और ये मैग्नेट भी बोलते हैं। तो इसमें किस तरह की रेखाएं बनी हुई, अब हम इस चुंबक से देखते हैं कि जो चुंबकीय रेखाएं बन रही थी पहले वो किस तरह का बनता है। तो इस चीज को दिखाने के लिए हमने क्या करा हुआ है, ये भी हमने चुंबक लिया है और उस चुंबक को हमने थोड़ा सा एक्सपेरिमेंटल अरेंजमेंट ऐसे बनाया है कि इसको हमने एक गत्ते पर चिपका दिया है ताकि ये ऐसे ऊपर की तरफ दिखता रहे। ये U जैसा दिख रहा है ना, ये है नाल चुंबक, और इसके ऊपर ये गत्ता चिपका दिया है ताकि हम इस गत्ते के ऊपर लोहे का या चुंबक का बुरादा जो अभी हम लोग प्रयोग कर रहे थे इसको इसके ऊपर डालेंगे। तो ये देखो यहाँ पर भी ऐसा ही पैटर्न अलग तरह से बनता हुआ दिख रहा है। ये जो बीच में चौकोर चौकोर छोटे छोटे दिख रहे हैं वो उसी नाल चुंबक का बीच का हिस्सा है, और ये लाइनें वैसे ही बन रही हैं जैसा कि अपने चुंबक के हिसाब से जो हमारा बार चुंबक था, जो डंडी जैसा सीधा वाला चुंबक था, उसमें भी इसी तरह का बन रहा है। तो आपका नाल चुंबक में और इस चुंबक में तो कुल मिला के हम ये देख रहे हैं कि जो चुंबक में जो लाइन्स ऑफ फोर्स, जो चुंबकीय रेखाएं हम स्कूल में पढ़ते थे, अभी भी पढ़ रहे हैं आप लोग, तो वो असल में जो लाइनें खींचते थे वो ऐसे ही दिखाने के लिए, दिखावे के लिए नहीं, बनाने के लिए, समझाने के लिए बताते थे। जबकि जो जो उसके बल हैं चुंबक से, जैसे जैसे आप दूर जा रहे हैं या चुंबक से कितनी दूरी पर हैं, वो ये बताने के लिए यही प्रयोग करके आप बहुत ही साधारण तरीके से देख सकते हैं कि जो लाइनें ऐसे खींची जाती हैं चुंबक के ऊपर, वो असल में जो चुंबकीय बल है वो इसी तरह से कम ज्यादा, जैसे जैसे आप दूर जाएं वैसे वैसे कम होता जाता है, और जैसे जैसे आप दोनों के ध्रुव के पास हो वैसे वैसे उसकी ताकत बढ़ती रहती है। अब जो अभी तक हमने चुंबक देखा वो चुंबक कैसा था, वो चुंबक इसको कहते हैं परमानेंट चुंबक। वो क्या, चुंबक पहले से ही चुंबक बना हुआ था, वो जो मटेरियल था, जिस पदार्थ का वो बना हुआ था, उस पदार्थ में ही चुंबकीय गुण थे, तो उससे बनाया गया। पर हमेशा उस तरह का चुंबक नहीं प्रयोग में होता। एक, अब अगर आपने ये पढ़ा होगा और अगर नहीं पढ़ा तो मैं बता देता हूँ, क्या होता है कि जब आप किसी भी सर्किट में, किसी भी परिपथ में धारा प्रवाहित करते हैं, इलेक्ट्रिकल करंट आप जब उसमें पास करते हैं, और इस तरह का सर्किट रहता है, इसमें जो ये बीच का ये पाइप जैसा दिख रहा है, ये एक खाली पाइप है, और उसके ऊपर ही ऐसे तार लपेटी हुई, जो आई, बड़ा सा आई लिखा हुआ है यहाँ पर, ये जो आई लिखा हुआ है ये बता रहा है कि इसमें से करंट पास हो रहा है इस वाले कॉइल में। तो आप, और जिस दिशा में ये इसमें धारा प्रवाहित हो रही है, अगर हम जिस दिशा में धारा प्रवाहित हो रही है उस दिशा में अपने अंगूठे को, अपनी हथेली को घुमाएं, तो जो हथेली के घूमने की दिशा अगर हमारे करंट के फ्लो होने की दिशा है, जो धारा के प्रवाहित होने की दिशा है, तो जो आपका अंगूठा है ये ऐसा थम्स अप जैसा बन गया ना, तो इसमें जो अंगूठा है वो बताएगा कि जो चुंबक बनेगा वो उसमें चुंबक में उसका, उसकी जो दिशा होगी चुंबकीय क्षेत्र की, वो किस तरह से होगा। तो इस चीज को भी हमने करने के लिए ये प्रयोग किया है, जिसमें हमने क्या किया है, ये कील ली है और कील के ऊपर हमने बहुत सारा तार ऐसे लपेट दिया है। ये जो सबसे नीचे दाहिनी तरफ आपको दिख रहा है ना, वो एक कील है, स्क्रू, पेंच है, और उस पेंच के ऊपर हमने बहुत सारी तार लपेट दी है, क्योंकि जितना उसमें चुंबक का गुण आएगा वो उस पर निर्भर करेगा कि कितनी ज्यादा उसमें तांबे की तार लपेटी हुई है, कोई भी तार, पर यहाँ पर हमने तांबे की तार ली हुई। और उस जो तार के नीचे ये घड़ी जैसा दिख रहा है, ये क्या है, आप सब जानते होंगे, कंपास है। कंपास क्या बताता है कि अगर आप इसको ऐसे रख दें तो इसकी सुई जो है उत्तर और दक्षिण की तरफ आती है, तो इससे हमें उत्तर दक्षिण का पता चलता है, दिशाओं का पता चलता है। अब हमने क्या किया है यहाँ पर, यहाँ पर जो ये आप देख रहे हैं कि सर्किट है, इधर बैटरी है, ये स्विच है और ये बल्ब यहाँ पर इसलिए लगा रखा है कि हम अब क्या करना चाह रहे हैं, इस पर जो ये स्क्रू है इसके ऊपर हम करंट फ्लो करना चाहते हैं, इसमें हम धारा प्रवाहित करेंगे। अब धारा प्रवाहित हो रही है कि नहीं हो रही है उसको देखने के लिए हमने ये बल्ब लगा दिया सर्किट में, ताकि आपको पता चले कि हाँ धारा प्रवाहित हो रही है। जब धारा प्रवाहित होगी तो ये बल्ब जलेगा, जब बल्ब जलेगा तो हम समझ जाएंगे कि इसमें धारा प्रवाहित हो रही है। चलो अब इसमें हम धारा को प्रवाहित करके देखते हैं। जैसे हमने ये स्विच को चालू करेंगे, ये धारा इसमें प्रवाहित होगी। अब देखने वाली बात, आप बल्ब की तरफ मत देखना, आप ये कंपास की तरफ देखना। क्यों? क्योंकि कंपास क्या कर रहा है, कंपास हमें बता रहा है कि उत्तर किधर है, दक्षिण किधर है। का मतलब है कि अगर हम चुंबक, एक दूसरा चुंबक यहाँ रख दें तो ये जो जो कंपास है इसकी दिशा कुछ बदल जाएगी, और अगर अभी जैसा है वैसा ही है। आप ये बल्ब तो जलेगा वैसे ही दिख जाएगा आपको, पर आप अभी अपना ध्यान जो है इस कंपास की तरफ रखना कि क्या हो रहा है जब हम इस स्विच को चालू करेंगे। अब ये स्विच को हमने चालू किया तो आप ये देखो कि ये हल्का सा ये घूम गया थोड़ा सा। तो क्या हुआ, इसका क्या मतलब हुआ कि ये जो हमने स्क्रू रखा था, पेंच के ऊपर जो हमने तार लपेट रखी थी, जब ये स्विच चालू किया तो ये बल्ब जल रहा है। का मतलब है कि इसमें से करंट फ्लो हो रहा है। जब करंट फ्लो हो रहा है तो ये कंपास इधर को घूम गया था। अभी फिर से इसको देखते हैं, ये इधर को घूमा। अब हम इसको बंद करेंगे तो ये वापस आ जाए। इसका क्या मतलब हुआ कि जो ये कंपास था ये चुंबक के क्षेत्र में आने से ये उसकी दिशा के हिसाब से थोड़ा सा दाएं बाएं घूमता, और जब हम इस स्विच को चालू बंद कर रहे थे तो भी ये दाएं बाएं घूम रहा था। इसका क्या मतलब हुआ कि जब इस सर्किट में परिपथ करंट फ्लो हो रहा है, धारा प्रवाहित हो रही है, तो यहाँ पर एक चुंबकीय क्षेत्र बन रहा है। इस चीज को क्या कहते हैं, इस आपने इस टर्म के नाम से सुना होगा, इसको कहते हैं विद्युत धारा का चुंबकीय प्रभाव। का मतलब है कि जब आप करंट पास करते हैं तो चुंबकीय क्षेत्र बनता है। और ये इसको जो ये जो आपने एक पेंच था इसके ऊपर ये लपेटा हुआ था, इसको बोलते हैं सोलेनॉइड। तो इस चीज को देखा। अब इसी चीज को थोड़ा सा वापस हम चुंबक के प्रयोग पर आएंगे, उससे पहले हम रेल की पटरी देखते हैं। क्या है कि चुंबक और रेल की पटरी का ऐसे तो कोई रिश्ता नहीं दिखता, पर थोड़ा सा दिखेगा जब हम अंत तक आएंगे ना तब तक। तो अब ये रेल की पटरी है। रेल की पटरी, ये उंगली ऐसे सिर्फ फोटो खींचने के लिए ली गई है, कोई ऐसे करना नहीं है। तो आपने क्या अगर रेल की पटरी को ध्यान से देखा होगा, ट्रेनों में अगर चलते हैं सब लोग हम लोग, अगर आप दूर से देखोगे तो ये जो दो पटरियां जहाँ, क्योंकि लोहे की पटरी तो किलोमीटर हजारों किलोमीटर लंबी होती है, पर पूरी 1000 किलोमीटर लंबी एक पटरी तो होती नहीं। तो क्या होता है कि छोटी छोटी पटरियों को जोड़ के लंबी पटरी बनाई जाती है। तो इसमें जो दो पटरियां जहाँ पर जोड़ी जाती हैं वहां पर थोड़ा सा गैप रखा जाता है, ताकि ये बिल्कुल चिपका के ऐसे नहीं जोड़ते जैसे घरों की टाइलें लगाते हैं, ऐसे नहीं लगाते पटरियों को। तो चुंबक के बीच में थोड़ी सी जगह चाहिए। वो थोड़ी जाती है थोड़ी सी जगह, क्योंकि जो ये ट्रेनें चलती हैं तो बरसात में चलती है, ठंड में चलती है और गर्मी में भी चलती है। तो गर्मी में एक तो ट्रेन के चलने से भी थोड़ी सी गर्म होगी, और जो गर्मी के दिनों में क्या होगा, एक हर पदार्थ का अपना ये गुण होता है कि जब आप उसको गर्म करते हैं तो वो साइज में थोड़ा सा बड़ा होता है। कौन सा पदार्थ है उस पर निर्भर करेगा कि वो कितने परसेंट तक बड़ा हो। ये गर्म करने से वो साइज में बड़ा हो जाता है। इसीलिए खाली जगह थोड़ी सी इसलिए छोड़ दी जाती है कि जब ये पटरी दाएं तरफ वाली और बाएं तरफ वाली पटरी थोड़ी थोड़ी बड़ी हो जाए तो वो ठीक है, आपस में उसको फैलने की जगह मिल जाए। तो गर्म करने से चीजें फैलती हैं, उसी के लिए ये थोड़ी सी जगह छोड़ी कि जब वो फैल जाए तो उतनी जगह उसको हो कि वो फैल के वहां आए। अगर हम ये जगह नहीं छोड़ेंगे तो क्या होगा कि हो सकता है कि वो एक दूसरे को इतना ठोकर मारे कि वो ट्रेन की पटरी टेढ़ी हो जाए। और हाँ, ये वाकई में बहुत ज्यादा ताकत से वो लगता है। अब इसी चीज को हम देखने के लिए कि क्या वाकई में ये कही सुनी बातें हैं कि किसी चीज को गर्म करने से वो फैल जाता है, उसका आकार बड़ा हो जाता है, ये कही सुनी बातें हैं या ऐसा वाकई में होता है, उसी चीज को करने के लिए ये छोटा सा छोटा सा प्रयोग है वो हमने दिखाया है। ऐसे पटरी पे जाके ये नापना नहीं है उंगली रख के कि कितना गैप है, ये सिर्फ आपको दिखाने के लिए है। अब यहाँ पर देखो कितनी क्या क्या चीजें हैं हमारे पास। ये जिस पर ये हाथ रखा हुआ है, ये तो आप अभी सब लोग पहचान गए हैं क्या है, ये थर्मामीटर है, इंफ्रारेड वाला थर्मामीटर। ये थोड़ा सा इसमें इंफ्रारेड लाइट निकलती हुई दिखती है, पर ये है वही जो कि कोरोना में सबने अभी अपने अपने सिर पे ये खाया होगा सबने ने। और इसके बगल में ये दो चीजें हैं। ये है एक छल्ला बीच में, आप हिंदी में अगर और हिंदी बोलना चाहते तो वलय बोल लो। और एक ये छोटा सा गोला है, इसके एकदम सिरे पर देखो ये पीतल का बना हुआ ये मटेरियल है। तो एक छल्ला है और एक ये गोला है। अभी ये क्यों है वो मैं बताता हूँ। और एक बगल में बीकर में ये पानी रखा है, और एक ये दिया जला रखा है। अब क्या है ये सब तामझाम, वो अभी हम आपको बताएं। तो यहाँ पर क्या हो रहा है कि हम देखते हैं जरा सा कि ये कितने ताप पर अभी ये गोला है। ये देखो दिख रहा है आपको स्क्रीन पे 27 डिग्री पे, इतना ही कमरे का तापमान होता है, तो वो कमरे के तापमान पे वो गोला है। ये दिए की जो लौ है वो तो ज्यादा गर्म होगी ऑफकोर्स। अब क्या है कि इस छल्ले का जो नाप है वो इसी गोले के हिसाब से उसी साइज का है। तो ये देखो जब हमने इसको इसके अंदर डाला तो ये आर पार हो गया। इसका मतलब क्या है कि जो गोला है अभी वो जो छल्ले का है रेडियस, उसके बराबर है या उससे थोड़ा सा छोटा है। अब क्या करते हैं कि अभी जो हमने बात कही कि जब चीजों को गर्म करते हैं तो क्या हो जाता है, वो फैल जाता है। तो अगर ऐसा है, ये गर्म करने से फैलता है, तो जब हम इसको गर्म करेंगे तो वो फैल जाएगा। जब फैलेगा तो वो जो छल्ले से पहले आसानी से जा आ पा रहा था वो नहीं जाना आना चाहिए। अगर ऐसा होता है तो हमारी बात सिद्ध हो जाएगी कि हाँ, चीजें गर्म करने से जो है वो फैल जाती है। तो अब इसको देखो हमने गर्म किया, इसी दिए के ऊपर हमने साधारण तरीके से इसको किया था। तो ये इसका तापमान देखो बढ़ के 50 डिग्री, ये 218 डिग्री तो दिए का तापमान रहा होगा। तो इसको हमने गर्म कर दिया। अब इसको गर्म करने के बाद अब हम इसको वापस से वैसे ही रखते हैं जैसे इसको रखा था। अब देखो इसको ये अंदर नहीं जा रहा। तो जो छल्ले में से गेम जो ये गोला था छोटा सा, ये आर पार चला जा रहा था। अब जब हमने इसको गर्म कर दिया तो आपको तापमान नाप के भी दिखाया, अब उसमें से नहीं जा रहा था। इसका क्या मतलब हुआ? इसका सिर्फ और सिर्फ एक ही मतलब हुआ कि जो गोला तो छोटा हुआ नहीं होगा, वो तो ऐसे ही रखा हुआ था। तो क्या हुआ कि जो ये गोला था वो गर्म करने की वजह से फैल गया, उसका आकार बड़ा हो गया। जो उसका आकार बड़ा हो गया तो वो उसमें से नहीं गया। अब हम इसको वापस से करके देखने की कोशिश करते हैं। ये ठंडा पानी यहाँ पर रखा हुआ था, उसमें हमने इस गोले को डाल दिया। तो पानी में जब गर्म गोले को रख देंगे तो क्या होगा, वो ठंडा हो जाएगा। जब ये ठंडा हो गया तो अगर गर्म करने से गोला बड़ा हुआ था, फैल गया था, तो क्या होगा कि ठंडा कर देने से वो वापस से खुल जाना चाहिए। अब देखो ये वापस से इसके अंदर जा रहा है और वापस चला आ रहा है। तो इस चीज को हमने, ये भी बड़ा आसानी से आप देख सकते हैं कि जो जो कहा जाता है कि हाँ, चीजों को गर्म करने से फैल जाता है, तो पृथ्वी में खाली जगह इसीलिए छोड़ी हुई थी कि गर्मी में वो थोड़ा फैल जाए और पटरी मुड़े नहीं काम में। तो इसके लिए वो खाली जगह छोड़ी जाती है। तो उस चीज को भी हमने प्रयोग करके देख लिया। अब वापस हम आते हैं जरा सा, एक चुंबक और पटरी का क्या कनेक्शन था, जरा सा उसको भी बना लेंगे। और ये देखो यहाँ पर क्या हो रहा था, दो जो चुंबक थे आपस में चिपक जाते हैं और या फिर एक दूसरे को प्रतिकर्षित करते हैं। जब चुंबक को इस तरह से रखा तो अब देखो मैं आपको बता रहा हूँ कि मैं इसे पुश कर रहा हूँ, लेकिन क्या वो चिपक नहीं रहा, क्योंकि ये उल्टे तरह से है। नॉर्थ और नॉर्थ एक तरफ होगा या साउथ एक तरफ होगा। इसी चीज को आसानी से समझने के लिए ये हमने लिया चुंबक। आप अगर अपना हेडफोन जो काम नहीं करता हो, जो काम कर रहा हो, उसको छोड़ने का कोई मतलब, जो हेडफोन जो ईयरफोन आपका काम नहीं कर रहा हो, उसको आप अगर तोड़ोगे तो उसमें छोटे छोटे इस तरह के चुंबक निकलेंगे जिससे बीच में छेद हो। आप ये प्रयोग कर सकते हो, या फिर किसी मोबाइल की दुकान पे चले जाए ना, उनके पास ऐसे टूटे फूटे बहुत पड़े रहते हैं, तो आप उनसे मांग के ये काम कर सकते हैं। तो उसमें क्या है कि एक को ऐसे रख दो। अब ये क्या था कि जो जो इससे उल्टे ध्रुव के थे, तो ये जब मैंने इसमें डाला तो ये चिपक गया। अब मैं इसको उल्टा करके डालूंगा। तो जब हम इसको उल्टा करके डाल रहे हैं तो ये देखो इसके ऊपर जो है ऐसे तो चिपक रहा था, लेकिन जब हम इसको उल्टा करके रख रहे हैं तो ये देखो नहीं चिपक रहा है, ये हवा में तैर रहा है। अब साधारणतः क्या होता है, आप अगर किसी चीज को, अगर आप किसी चीज को ऊपर से ऐसे छोड़ो तो गुरुत्वाकर्षण की वजह से क्या होता है कि वो नीचे जमीन की तरफ गिर जाता है। लेकिन यहाँ पर चुंबक क्या हो रहा है कि जब हमने चुंबक को छोड़ा तो वो चुंबक से चिपका नहीं। तो क्या हुआ, तो उसका जो भार था ऊपर वाले चुंबक का, उसके साथ क्या हुआ, उसको इस नीचे वाले चुंबक ने उतने ही बल लगा के उसको रोक दिया ऊपर। तो क्या हुआ इसमें, कुल मिला के क्या हुआ कि एक चुंबक दूसरे चुंबक को उसमें आपस में चिपकने लगे। इसको, इसके लिए हिंदी में क्या शब्द है पता नहीं, होना भी जरूरी भी नहीं। तो इंग्लिश में कहते हैं मैग्नेटिक लेविटेशन, मतलब एक चुंबक दूसरे चुंबक के ऊपर तैर रहा है, ऐसा ही हो रहा है ना। जो इसका वजन था, वो वजन जो कि ग्रेविटी ने उस पर डाला था, उसको वो नहीं चिपकाने दे रहा है। अब इसी चीज को समझने के लिए हमने ये देखो क्या बनाया, वो हमने नहीं बनाया, ये तो हमने खरीदा है, हम तो आपको सिर्फ समझा रहे हैं। इसमें क्या है कि ये ग्लोब बना हुआ है, इसमें हिंदुस्तान भी है, देखो कितना सुंदर, और पूरा मानचित्र बना हुआ है विश्व का, और इसमें भी चुंबक का सिस्टम लगा हुआ है इसके ऊपर। और ये जो आप देख रहे हैं ये काला, और जिसमें ये एलईडी नीली पीली जल रही है, लाल और नीली, इसके ऊपर भी उसी तरह का चुंबक का सिस्टम बना हुआ है। तो इस चुंबक को इस चुंबक के वजन से हम लटका देना चाहते हैं, ताकि ऐसे अगर किसी चीज को लटकाएं तो रस्सी बांध के लटका सकते हैं, लेकिन यहाँ पर क्या है कि बिना रस्सी के ही हम इसको लटका देंगे। अभी अगर आप इसको छोड़ देख रहे थे कि जब हम इसको छोड़ रहे थे तो वो गिर जा रहा था, अब हम क्या करेंगे, इस चुंबक को इस चुंबक के सहारे से रख देंगे, और ये जरा सा इसको शुरू में सहारा लगता है, और हमने ये सहारा निकाल लिया। अब आप क्या देख पा रहे हो, अब इसको गौर से देखो इस वीडियो। यहाँ पर क्या है, यहाँ पर कोई एक दूसरे के साथ संपर्क में नहीं है ना, ये जो ग्लोब है वो इसके संपर्क में ऐसे नहीं है। अगर मैं इधर ये चम्मच हटाऊं इसमें से प्लास्टिक का, तो आर पार चला गया। अब मैं इसको जरा सा घुमा देता हूँ, अगर हम इसको थोड़ा सा घुमा देते, ये हवा में बिल्कुल लटका हुआ है, ये ऐसे लटका हुआ है और ये घूम भी रहा है। तो ये चुंबक का जो वजन है, जो ग्लोब का वजन है मॉडल का, वो इस चुंबक ने इसको साध लिया है, और ये बिल्कुल ऐसा तैरता हुआ दिख रहा है। इसी सिद्धांत पर जो है विकसित देशों में, डेवलप्ड कंट्रीज में मैग्नेटिक लेविटेशन ट्रेनें चलती है, जिसमें क्या काफी स्पीड में भी चलती है। वो इसी चक्कर में कि ट्रेन जो है वो पटरी पे नहीं रुकता, ये पटरी और पटरी का कनेक्शन था, वहाँ जो फैलने वाली पटरी, इसीलिए मैंने थोड़ा पटरी की भी कहानी बता दी, उसमें भी जो विज्ञान था वो भी बता दी। तो इस तरह से हम लोगों ने क्या क्या देखा कि पटरी जो है, जो चुंबकीय बल है वो कैसे काम करते हैं, कितने तरह के होते हैं, और किस कंडीशन में वो चिपकते हैं, और किस कंडीशन में वो एक दूसरे को से दूर भगाते हैं। तो ये छोटे छोटे प्रयोग हैं, आप आसानी से घर पे कर सकते हो सब लोग, और एंजॉय कर सकते हैं, खेल खेल में सीख सकते हैं, खेल सकते हैं। ठीक है, और
थैंक यू सर, आपने बहुत ही सिंपल और सरल भाषा में भौतिक विज्ञान से, मैग्नेट से जुड़ी हुई बहुत सी हमें बातें बताई, और इतनी आसानी से हमने समझ लिया रेल की पटरी को, चुंबक को। तो थैंक यू सर। अब मैं इनवाइट करना चाहूंगी मिस रीना को, वो प्रोग्राम को आगे बढ़ाएं।
Thank you, teacher. Thank you so much, sir, for your demonstration of the physics of daily life with attractive model. सर, आपके द्वारा दिया गया टॉक कठिन से कठिन विषय को भी सरलता से हम विद्यार्थियों तक पहुंचा देता है। सर, आपका बहुत बहुत धन्यवाद। आइए अब हम बढ़ते हैं केमिस्ट्री की ओर। केमिस्ट्री की पूरी टीम की ओर से आपके लिए हम लेकर आए हैं कुछ देखी अनदेखी घटनाएं। आइए चलते हैं केमिकल इल्यूजन की कुछ घटनाओं पर, जहां पर आपको दिखेगा जो तो आपको ऐसा लगेगा कि ये मैजिक है, लेकिन उसके पीछे छुपा हुआ रसायन आज हम आपके सामने प्रदर्शित करने जा रहे हैं। चलिए चलते हैं केमिकल इल्यूजन की ओर।
संयोजन, वियोजन, विस्थापन, द्विस्थापन, कई रासायनिक क्रियाओं का विवरण। हाँ, दिमाग में चलती है कई क्रियाएं, लेकिन सबसे अनोखी विज्ञान है रसायन। तो लेट्स स्टार्ट विद आवर फर्स्ट एक्सपेरिमेंट, जिनी इन अ बॉटल। तो चलते हैं एक ऐसे एक्सपेरिमेंट की तरफ जिसमें एक बोतल में बंद जिनी को आजाद करके अपनी सारी विशेष पूरी।
टू है। अब हम इसे एक दूसरे बॉटल में डाल रहे हैं और हम यहाँ पर एक कैटलिस्ट यूज कर रहे हैं MnO2, जिसे हम धागे से बांधे हुए हैं। अब ये कैटलिस्ट हम धागे के सहारे इस बॉटल में डाल रहे हैं और इसके बाद हम ढक्कन को क्लोज कर देंगे, ठीक है। और हम रब करेंगे इसे, देखते हैं कि इसमें से जीनी बाहर आ रहा है कि नहीं। सब लोग विश मांग लो, 1 2 3। नाउ देखे जीनी आता है कि नहीं। ये जीनी आ गया।
अब इस रिएक्शन की केमिस्ट्री समझते हैं। कोई जिनी देखने में तो जिनी था, लेकिन है सबके पीछे साइंस। यहाँ पर जो रिएक्शन दिख रही है, जो डिस्प्ले हो रही है, वो एक रिएक्शन एक्सोथर्मिक रिएक्शन। एक्सोथर्मिक रिएक्शंस कौन सी रिएक्शंस होती हैं? जिसमें एनर्जी निकलती है साथ में। हम लिखी हुई रिएक्शन में देख सकते हैं कि प्लस एनर्जी लिखा हुआ है। तो यहाँ पर क्या होता है, रिएक्शन एक्सोथर्मिक होती है। वाटर जो होता है वो वेपर की फॉर्म में कंडेंसेस आउट एज वेपर, और जो ऑक्सीजन गैस पूरी प्रोसेस में निकलती है वो एनर्जी रिलीज होने की वजह से फोर्स होकर बाहर आती है, जो हमको ऐसा लगता है कि बोतल से बाहर जिनी आ रही है।
तो चलिए, आपने अभी देखा कि किस प्रकार से बोतल से हमने जिनी को बाहर निकाला। सो आवर नेक्स्ट एक्सपेरिमेंट इज नॉन बर्निंग पेपर। अब हम चलते हैं। आपने देखा होगा, हम सभी ने कागज को जलते हुए देखा है, लेकिन आज हम एक ऐसा कागज देखेंगे जो जलाने पर जलता ही नहीं है। तो चलिए चलते हैं, द एक्सपेरिमेंट नॉन बर्निंग पेपर।
सबसे पहले हम 50% वाटर और अल्कोहल का सॉल्यूशन लेते हैं, जिसमें हम किसी पेपर या नोट को अच्छे से डिप करते हैं। आप देख सकते हैं पेपर अच्छे से भीग गया है। अब इसको हम मैच बॉक्स की हेल्प से जलाते हैं। तो देखिए, पेपर ने अच्छे से आग पकड़ लिया है, बट हमारा पेपर नहीं जला है। अब हम फिर इसको एक बार डिप करके दिखाते हैं और हम इसको फिर से मैच बॉक्स की हेल्प से जलाएंगे। और ये देखिए, दोबारा हम जलाते हैं फिर भी हमारा पेपर जलता नहीं है। तो ये हुआ ना जादू। देखिए, हमारा पेपर पूरी तरह सुरक्षित है।
तो देखा आपने, एक पेपर को जलाने पर भी वह नहीं जला और हमारा पेपर पूरी तरह से सुरक्षित है। तो ये जादू कैसे हुआ? क्योंकि जब हमने उस कागज को अल्कोहल और वाटर के सॉल्यूशन में डिप किया, तो जो वाटर है वो तो पेपर के अंदर एब्जॉर्ब हो गया, लेकिन जो अल्कोहल की ड्रॉपलेट्स थी वो पेपर के ऊपर ही रही। और जब हमने उस पर मैच बॉक्स से आग जलाई, तो क्या हुआ? जो अल्कोहल के मॉलिक्यूल्स थे उन्होंने आग पकड़ी, लेकिन जब तक कि अल्कोहल जल पाता, जिस तापमान पर अल्कोहल जलता है वो तापमान वेपर को मतलब वाटर को इवेपोरेट करने के लिए काफी नहीं होता। इसलिए जितनी देर तक अल्कोहल जलता है, उसके बाद जैसे ही अल्कोहल जल जाता है, वो तापमान क्योंकि सफिशिएंट नहीं था, तो वाटर वेपर में कन्वर्ट नहीं हो पाता और कागज गीला ही रहता है, और गीला कागज जल नहीं सकता। तो ये था केमिस्ट्री का मैजिक, और इसके पीछे थी रसायन विज्ञान।
आई होप सबको मजा आ रहा होगा ये एक्सपेरिमेंट्स देखकर। आइए अब हम दिखाते हैं आपको एक जादू रसायन का। इसमें बीकर में रखा एक सॉल्यूशन खुद ही रंग बदलता है। So let's move on to next experiment, that is Briggs-Rosher reaction, oscillatory reaction.
ब्रिग्स-रोशर ऑसिलेटरी रिएक्शन परफॉर्म करने के लिए हम 3 सॉल्यूशंस लेंगे। सॉल्यूशन ए, जिसमें कंपोनेंट्स हैं पोटेशियम आयोडेट और सल्फ्यूरिक एसिड। इस सॉल्यूशन को स्टर होने के लिए रख देंगे। इसके बाद हम इसमें सॉल्यूशन बी मिक्स करेंगे, जिसमें कंपोनेंट्स हैं मेलोनिक एसिड, मैग्नीज सल्फेट एंड स्टार्च। इन दोनों सॉल्यूशंस के इक्वल अमाउंट को स्टर होने के लिए रख देंगे। इसके बाद इस सॉल्यूशन में सॉल्यूशन सी मिक्स करेंगे, जिसकी कंपोनेंट है हाइड्रोजन पेरोक्साइड। तीनों सॉल्यूशंस का इक्वल अमाउंट लेने पर हम देखेंगे पहले अंबर कलर प्रोड्यूस होता है जो धीरे धीरे ब्लू कलर में कन्वर्ट होके इसके बाद कलरलेस होने के बाद सेम साइकिल प्रोड्यूस करता है अंबर कलर टू ब्लू, ब्लू टू कलरलेस। लास्ट में 14 ऑसिलेशंस होने के बाद ये साइकिल कंप्लीट हो जाती है और फाइनली हमें ब्लू कलर का सॉल्यूशन प्राप्त होता है जो स्टार आयटन कॉम्प्लेक्स की वजह से है।
तो आइए अब इसकी केमिस्ट्री को समझते हैं। यहाँ पर एक MnSO4 है जो कैटलिस्ट की तरह यूज हुआ है। स्टार्च एक इंडिकेटर है जो ब्लू कलर का कॉम्प्लेक्स बनाता है आयोडीन के साथ मिलने पर। H2O2 यहाँ पे ऑक्सीडाइजिंग और एक रिड्यूसिंग एजेंट की तरह काम किया है। मेलोनिक एसिड और H2SO4 जो है वो फ्री आयोडीन मतलब I2 को I- में रिलीज करते हैं। जो अंबर मतलब पीले रंग जैसा एक कलर निकलता है वो आयोडीन प्रोड्यूस होने की वजह से निकलता है, जो दिखाता है कि मिक्सचर में आयोडीन रिलीज हो रही है। उसके बाद वो कलरलेस होता है। कलरलेस का मतलब है कि जितनी आयोडीन रिलीज हुई थी वो सारी कंज्यूम होके वापस I- बन चुकी है। और जो डीप ब्लू कलर हमको सोल्यूशन में मिलता है वो आयोडीन और स्टार्च के इंटरेक्शन होने पर एक कॉम्प्लेक्स बनता है, उससे डीप कलर कॉम्प्लेक्स ब्लू कलर का हमें दिखाई।
तो आपने अभी देखा कि किस प्रकार से एक सॉल्यूशन डिफरेंट डिफरेंट कलर शो करता है और जानी उसके पीछे की केमिस्ट्री। चलिए अब हम चलते हैं टूथपेस्ट बनाने की ओर। ये एक्सपेरिमेंट है। जैसे कि आप जानते हैं हाथी के दांत कितने बड़े बड़े होते हैं, तो अगर हाथी के बराबर दांत हमारे हो जाए तो एक टूथपेस्ट एक ही दिन में फिनिश हो जाएगा। तो यहाँ पर जो हम एक्सपेरिमेंट कर रहे हैं वो है एलिफेंट टूथपेस्ट एक्सपेरिमेंट। तो आपने सोचा है कि कभी कि हाथी के दांतों को अगर पेस्ट करना हो तो कितना हमें टूथपेस्ट चाहिए। तो अगला एक्सपेरिमेंट हमें बनाना सिखाएगा बहुत सारा टूथपेस्ट। तो चलिए हम चलते हैं नेक्स्ट एक्सपेरिमेंट की ओर।
इस एक्सपेरिमेंट में हम हाइड्रोजन परऑक्साइड यूज़ कर रहे हैं जो कि 30% है। यह हाइड्रोजन परऑक्साइड हम 10 से 15 ml यूज़ करेंगे। यह हाइड्रोजन परऑक्साइड है। अब इसके अंदर हम डाइल्यूटेड सॉप सॉल्यूशन डालेंगे जो कि अच्छे फॉर्म बनाने के लिए होता है। अब हम यहाँ पर कलर ऐड कर रहे हैं जो कि हम ग्रीन कलर यूज़ कर रहे हैं और इसमें हम ऑरेंज कलर यूज़ कर रहे हैं। यह कलर हम हमारी चॉइस के आधार पर ले सकते हैं। अब इसके अंदर हम पोटेशियम आयोडाइड यूज़ करेंगे जो कि कैटलिस्ट का काम करता है। जैसे ही हम इसके अंदर पोटेशियम आयोडाइड डालते हैं आप देख सकते हैं इसमें एलिफेंट टूथपेस्ट बनकर रेडी हुआ है। इस प्रकार से हम इसमें भी डालेंगे और एलिफेंट टूथपेस्ट आप देख रहे हैं ऑरेंज कलर का इसमें बना हुआ है।
तो आपने देखा कि यहाँ पर आपको 2 कलर के टूथपेस्ट बना के दिखाए गए हैं। आप अपनी पसंद का चूज कर सकते हैं। इसके पीछे की केमिस्ट्री भी आपको वीडियो में बता दी गई है। होता क्या है, जब सोप सॉल्यूशन और वाटर का मिक्सचर लेते हैं, सोप सॉल्यूशन और हाइड्रोजन पेरोक्साइड का मिक्सचर लेते हैं और उसमें Ki एज अ कैटालिस्ट डालते हैं, तो हाइड्रोजन पेरोक्साइड के बॉन्ड ब्रेक्स होते हैं और ये कन्वर्ट होता है वाटर एंड ऑक्सीजन में। ये वाटर और ऑक्सीजन सोप सॉल्यूशन यानी फॉर्म के साथ मिक्स होके बाहर की तरफ उछल जाता है। और हम कह सकते हैं कि यहाँ पर हम इस तरीके का एक्सपेरिमेंट दिखा के हम बता सकते हैं कि ये एक हाथी मतलब एलिफेंट्स के लिए टूथपेस्ट नहीं है, इसके पीछे भी एक सुंदर सी और बहुत ही अट्रैक्टिव केमिस्ट्री है। तो चलिए चलते हैं हमारे नेक्स्ट एक्सपेरिमेंट।
इस मजेदार एक्सपेरिमेंट के बाद चलते हैं ग्लोइंग टॉर्नेडो की तरफ। ग्लोइंग टॉर्नेडो मतलब एक चमकता हुआ टॉर्नेडो।
आइए बच्चों, अब हम देखते हैं कि किस तरह से अंधेरे में चीजें चमकती हैं। इसके लिए हम ले रहे हैं ये यूवी कैबिनेट बॉक्स, हरे और नीले रंग की डाई और साथ में थोड़ा सा सादा पानी। चलो अब जल्दी से जादू देखने के लिए लाइट को बंद करते हैं। अब आपके सामने हरे रंग का जगमगाता हुआ टोर्नेडो दिखाई देगा और ये देखिए आपका टोर्नेडो। ये हरा रंग आपके सामने और भी गाढ़ा होता जाएगा। ये देखिए, लेकिन अब हम हरे रंग से नहीं, हम तो नीले रंग से टोर्नेडो बनाएंगे। देखिए, मजा आया ना? इसी तरीके से आपकी घड़ी की सुइयां और टी शर्ट्स के कार्टून अंधेरे में चमकते हैं।
तो क्या ये सच में जादू था? ऐसे चीजें चमक नहीं सकती, कुछ तो साइंस होगी। दिस प्रोसेस इज नोन एज केमिल्यूमिनेशन। इसमें क्या होता है, कुछ ऑर्गेनिक डाई या मॉलिक्यूल यूवी लाइट को अब्सॉर्ब कर लेते हैं। एब्सॉर्ब करने के बाद वो ग्राउंड स्टेट मतलब कम एनर्जी से एक एक्साइटेड स्टेट, एक हायर एनर्जी स्टेट में पहुंच जाती है। पहुंचने के बाद कोई भी चीज एक्साइटेड या हाई एनर्जी स्टेट में स्टेबल नहीं होती। वापस जब वो नीचे की तरफ स्टेबल या ग्राउंड स्टेट में आती है तो वो एक एप्रिशिएबल अमाउंट ऑफ एनर्जी को रिलीज करती है, और वही एनर्जी हमें विजिबल रीजन मतलब जो हम अपनी आंखों से देख सकते हैं उसमें दिखाई देती है, जिसकी वजह से वो चीजें हमें चमकती है।
तो आपने अभी देखा एक ग्लोइंग टॉर्नेडो। अब हम चलते हैं एक ऐसे एक्सपेरिमेंट की ओर जिसमें आप देखेंगे कि एक अंडा, एग जो है वो पानी में डूब नहीं रहा है। तो अगर आप जनरली सोचेंगे एक पानी में एग को डालेंगे तो वो डूब जाएगा, लेकिन हम आपके सामने प्रदर्शित करने जा रहे हैं एक ऐसा प्रयोग जिसमें अंडा पानी में नहीं डूबेगा। तो चलिए एक्सपेरिमेंट की ओर।
ये है हमारे पास एक बीकर में प्लेन वाटर और सादा पानी। ये है हमारे पास एक बीकर में खारा पानी और सॉल्ट सॉल्यूशन। ये है हमारे पास 2 नींबू और ये हैं 2 अंडे। अब हम एक एक नींबू को एक एक बीकर में डाल के देखेंगे और हम देखते हैं कि सादे पानी वाला नींबू डूब गया और खारे पानी वाला नहीं डूबा। अब हम सेम एक्टिविटी अंडों के साथ करेंगे। अंडे भी नींबू की तरह आइडेंटिकल हैं और हम देखते हैं कि सादे पानी वाला अंडा डूब गया और सॉल्ट सॉल्यूशन वाला नहीं डूबा। ये थी हमारी वाटर डेंसिटी एक्टिविटी।
तो मजा आया आपको? आपने देखा कि आपने यहाँ पर देखा कि एक साइड तो क्या हो रहा है, नींबू या अंडा डूब जा रहा है और दूसरी साइड नहीं डूब रहा है। आपने पढ़ा होगा उत्प्लावन बल के बारे में, बॉयंट फोर्स। होता क्या है कि एक बीकर में क्या था कि जो है सॉल्ट मिक्स था तो उसकी डेंसिटी ज्यादा हो गई है, और दूसरा क्या है, एक सादा पानी है। तो सादे पानी में जो हम अंडे को डिप करते हैं तो उसका वेट ज्यादा है किसके कंपेरिजन में, सिंपल वाटर की। लेकिन अगर हम दूसरी साइड सॉल्ट वाटर की बात करते हैं तो वहां पे सॉल्ट वाटर की डेंसिटी ज्यादा हो गई है, जिसके कारण उत्प्लावन बल यानी बॉयंट फोर्स की हम कह सकते हैं क्वांटिटी भी ज्यादा हो गई है, इसलिए अंडा वहां पर तैर रहा है क्योंकि उसकी कंपेयर में अंडा क्या हो गया है, हल्का हो गया। तो चलिए, आपने अभी देखा केमिस्ट्री का जादू। अब हम चलते हैं हमारे नेक्स्ट एक्सपेरिमेंट की ओर।
आसमां के इंद्रधनुष को उतार लाए हम पानी के गिलास में, क्या ऐसा संभव है? देखते हैं सोच विचार। तो अब हम अपना नया एक्सपेरिमेंट देखते हैं जिसमें हम ग्लास, रेनबो इन अ ग्लास।
ये है हमारे पास एक टेस्ट ट्यूब। और ये है 3 अलग रंग के चीनी और पानी के घोल। ये जो हरे रंग का घोल है इसमें चीनी की मात्रा सबसे ज्यादा है और ये जो सफेद रंग का घोल है इसमें चीनी की मात्रा थोड़ी कम है। इस रंग के घोल में चीनी नहीं है। अब हम टेस्ट ट्यूब के अंदर सबसे पहले हरे रंग का चीनी और पानी का घोल डाल रहे हैं। अब हम हरे रंग के चीनी और पानी का घोल डालने के बाद हम सफेद रंग का चीनी और पानी का घोल डालेंगे। आप लोग देख सकते हैं कि जो हरे रंग का चीनी और पानी का घोल है वो सफेद रंग के चीनी और पानी के घोल के साथ नहीं मिल रहा है। अब हम अपने तीसरे रंग का घोल जिसमें कि चीनी नहीं है वो टेस्ट ट्यूब के अंदर डाल लेंगे। इसमें आप लोग देख सकते हैं कि तीनों अलग अलग रंग के घोल एक दूसरे के अंदर नहीं मिल रहे हैं। और ये इस तरह से हमारा भारत का झंडा बनकर तैयार है। तो ये हुआ हमारा शुगर डेंसिटी एक्सपेरिमेंट।
इसके पीछे की केमिस्ट्री वीडियो में एक्सप्लेन थी, लेकिन हमको पता है कि जो ज़्यादा डेंस चीज़ें होती हैं, मतलब भारी चीज़ें होती हैं, वो नीचे की तरफ आ जाती हैं और हल्की मतलब लेस डेंस चीज़ें ऊपर की तरफ आ जाती हैं। तो यहाँ पर ऐसे ही हमने 3 कलर का सोल्यूशन बनाया है। अब क्योंकि हरा वाला रंग सबसे नीचे है, इसका मतलब वहाँ पर जो शुगर डेंसिटी सोल्यूशन की यूज करी गई है वो सबसे कम है। कम होने की वजह से वो सबसे नीचे बैठ गया। जो व्हाइट कलर का सोल्यूशन था वो उससे ज्यादा डेंसिटी का था, इसीलिए बीच में आ गया। और जो सेफ्रन यानी नारंगी रंग का जो सोल्यूशन था
जो सबसे डेंस सॉल्यूशन था वो सबसे नीचे आ गया, देन मिडिल डेंसिटी एंड देन जिसकी डेंसिटी सबसे कम थी। इस तरीके से हमने यहाँ पर बना दिया अपने भारत का झंडा, क्योंकि हम भारत में रहते हैं और हमसे जुड़ी चाहे फिजिक्स है, केमिस्ट्री है, एस्ट्रो है, हम सब योगदान देते हैं पूरे विश्व को, पूरे भारतवर्ष को। तो देखिए हमने केमिस्ट्री की मदद से यहाँ पर बना दिया बीकर टेस्ट ट्यूब में अपने भारत का झंडा, और इसके पीछे की केमिस्ट्री थी डिफरेंस इन डेंसिटीज ऑफ दैट कलर्ड सॉल्यूशन। चलिए तो अब हम बढ़ते हैं अपने नेक्स्ट एक्सपेरिमेंट की ओर, जो है केमिकल कट एक्सपेरिमेंट। नाउ वी वुड लाइक टू शेयर अवर लास्ट एक्सपेरिमेंट, दिस इज केमिकल कट। सो लेट्स सी दैट व्हाट हैपन इन दिस एक्सपेरिमेंट।
सबसे पहले हम लेंगे FeCl3 सॉल्यूशन। हमने वाटर में FeCl3 डालकर इसका एक सॉल्यूशन बनाया था, उसे हम लेंगे एक बीकर में। उसके बाद हम लेंगे अमोनियम थायोसाइनेट सॉल्यूशन, इसे भी हमने बना कर रखा था। इसे हम लेंगे दूसरे बीकर में। और आखिर में हम लेंगे सोडियम फ्लोराइड सॉल्यूशन, ये भी हमने वाटर में सोडियम फ्लोराइड डालकर बनाया था। इसे हम डाल लेंगे तीसरे बीकर में। तो अब हमारे तीनों सॉल्यूशन रेडी हैं। अब जैसा कि आप देख सकते हैं हमारे हाथ बिल्कुल साफ है, कुछ लगा हुआ नहीं है इन पर। हम लेंगे कॉटन, उसे भिगोएंगे अमोनियम थायोसाइनेट में और उसे अपने हाथों पर लगाएंगे। उसके बाद हम लेंगे एक चाकू। ध्यान रहे चाकू की धार तेज नहीं होनी चाहिए। उसे हमने एफिशिएंटली सॉल्यूशन में डाला है और अपने हाथों पर लगाएंगे। और जैसा कि आप देख सकते हैं ये एकदम रियल ब्लड की तरह दिख रहा है। ये जो कट दिख रहे हैं बिल्कुल रियल लग रहे हैं। एक दो बार हम और ट्राई करेंगे इसे। फिर से एफिशिएंटली सॉल्यूशन में डिप किया है और देखिए ये बिल्कुल फिल्मों में कट बताते हैं उसी तरह ये कट दिख रहा है। ये एक बार और देखिए इसे, क्यों लग रहा है ना एक रियल कट। और हम इसे वापस मिटा भी सकते हैं। हम लेंगे एक कॉटन, उसे डिप करेंगे सोडियम क्लोराइड सॉल्यूशन में और लगाएंगे अपने हाथों पर। और जैसा कि आप देख रहे हैं जो रेड कलर था, जो ब्लड कलर दिख रहा था, वो अब सब कुछ मिट रहा है, बिल्कुल गायब हो चुका है। तो यही था हमारा केमिकल कट एक्सपेरिमेंट।
तो आशा है आपको बहुत ही सुंदर लगा होगा ये एक्सपेरिमेंट। अब हम सभी देखते हैं फिल्मों में कि कितने भयंकर भयंकर सीन दिखाए जाते हैं, एकदम रक्त वक्त के, है ना। तो यहाँ पर इसके पीछे की केमिस्ट्री क्या है? ऐसा क्या हुआ कि हमको ऐसा लग रहा है कि हाँ ये रियल ब्लड है और हाथ काट दिया गया है? तो हाथ काटा नहीं गया है, इसके पीछे की केमिस्ट्री क्या थी? इसमें अमोनियम थायोसाइनेट जो है वो FeCl3 से रिएक्शन करके बनाता है आयरन थायोसाइनेट। और ये जो प्रोडक्ट है आयरन थायोसाइनेट, इसका कलर एकदम रक्त के समान लाल होता है, बिल्कुल मैच करता है रक्त से। तो ऐसा लगता है कि हमने सच में ही हाथ को काट दिया है और रक्त निकाल गया है। तो एक्चुअल में वो क्या है? वो है किसका कलर? वो है आयरन थायोसाइनेट का कलर। तो इस तरीके से आज हमारे बहुत ही इंटरेस्टिंग जो है केमिस्ट्री के एक्सपेरिमेंट आपके सामने प्रदर्शित किए गए। वैसे तो बहुत कुछ है, बहुत कुछ था जिसको कि आपके सामने हम दिखाना चाहते थे, लेकिन फिर भी कोशिश की गई कि जो है बहुत इंटरेस्टिंग और छोटे से छोटे एक्सपेरिमेंट हम आप सभी बच्चों के सामने प्रदर्शित करें, जो जो कि आपके अंदर जगाएं कि वास्तव में केमिस्ट्री बहुत ही इंटरेस्टिंग है, बहुत ही नॉलेजेबल है। आप इसमें अगर सच में ध्यान से और बहुत इंटरेस्ट से पढ़ते हैं तो आपको ये बहुत ही मजेदार लगती है। तो इस प्रकार से हमने रसायन विज्ञान से भरे कौतूहलपूर्ण प्रयोगों को पूरा किया। इसमें हमारे पूरे जो हमारे प्रोफेसर्स हैं केमिस्ट्री डिपार्टमेंट के, हमारे कोर कमिटी मेंबर्स हैं, हमारे स्टूडेंट्स हैं और हमारे साथी हैं जो वॉलेंटियर हैं, उन्होंने बहुत ही मेहनत की और बहुत ही सुंदर तरीके से आप सबके सामने केमिस्ट्री को प्रदर्शित किया। हम आशा करते हैं कि जितने भी बच्चे वर्चुअली और यहाँ पर जो फिजिकली प्रेजेंट हैं सभी को ये एक्सपेरिमेंट बहुत ही सुंदर लगे होंगे और बहुत ही मनोरंजक साबित हुए होंगे। तो अब हम चलते हैं अपने अगले कार्यक्रम की ओर।
प्राकृतिक रूप से चांद तारे जितने खूबसूरत हैं उतना ही खूबसूरत और मजेदार है उनका विज्ञान। So here I would like to invite from Department of Astro or DASI team to conduct virtual experiments showing what happens when a star dies and what happens when we play with the solar system and its gravity. So I would like to invite Anshuman Tripathi to conduct the further program.
तो जैसा हम जानते हैं शुरू से ही एस्ट्रोनॉमी और एस्ट्रोफिजिक्स एक ऐसी विज्ञान की शाखा रही है जो हमेशा से ही लोगों को आकर्षित और रोमांचित करती रही है। और जब बात ब्रह्मांड और उसके रहस्यों को जानने की हो तो कौन नहीं जानना चाहेगा। तो चलिए इसको और बारीकियों से जानने के लिए हम बुलाना चाहते हैं हमारे एस्ट्रोनॉमी डिपार्टमेंट के एक्सपर्ट डॉक्टर मनोहिता मैम को। वो आपको दिखाएंगी journey through the cosmos.
Thank you. Just let me share my screen. Is it visible?
Yes, ma'am.
Okay. So let's start the session, The Journey into the Cosmos, which is by our DASI team, Department of Astronomy, Astrophysics and Space Engineering. And the members are listed here. We have this many people and many more also. So astronomy is perhaps one of the oldest branches of science where people looked into the sky in the very ancient times and wondered what those twinkling dots are. The stars were not like objects of wonder, but they were of daily importance, where they looked at the sky to decide when the hunting time is, when the time to gather is, and so on and so forth. With the advancement of knowledge, right now the question we ask is how the universe began, how the first stars and galaxies were formed, how the stars are born and where do they die, how gravity works, and what happens around a black hole, and questions regarding Earth's atmosphere. This is what now current days astronomers work on, and also the members of DASI are involved in pursuing in their research work. We already heard about Galileo and the telescope that he made from Professor Sharma. So, just to reiterate that with Galileo, who made the first telescope to look at the sky, began a new era where we use telescope to look at the sky and image it much better and to further distances so that we expand our limits of understanding. In the days before the compass and GPS, stars were an integral part of human life. Navigation depended critically on the position of sun and the stars, particularly the stars in the night. People knew their positions around the globe by looking at the positions of the stars. Not just position, also time was determined by the motions of the celestial bodies. For example, one of the earliest calendars was the lunar calendar, which was made 10,000 years ago, which was based on the different phases of the moon. As knowledge progressed, one of the first questions we asked is, where are we in the grand scheme of universe? This is our total address, and here each small dots in this particular image are basically galaxies or collections of galaxies. And we are in such a local collection of galaxy called the local supercluster or the Virgo supercluster, which comprises of small groups of galaxy. In one such group called the local group is our own Milky Way, and tucked away in one of the small spiral arms, very outer spiral arms of Milky Way is our sun. Around the sun there are 8 planets. One of the such planets, the third planet, is our own Earth where we live. Now let's start talking about the building blocks of our sky. So what is the first building block that we immediately see when we look up in the sky? That starts from the small scale. The first is the planets. We have the rocky planets like Earth and the massive gaseous planets like Jupiter. Not just our solar system planets, but hundreds and thousands of such planets are being discovered in other stellar systems as well. These are called exoplanets. And just by understanding how these exoplanets came into being and by studying them, we can say how planets formed, how their atmosphere behaved, what are the chemical that we very nicely see in the previous talks, all those chemicals, how they came into being. And finally, is there any evidence of life? So that can be very well understood by studying these planets. Next, we have the star. Of course, in our case, it's our very own beloved sun. What are stars? Stars are basically big balls of gases where nuclear reactions are going on in their center. So two nuclei are fusing to form very newer elements, newer nuclei. And in the process, they are generating huge amount of energy, which is powering the star, giving away lots and lots of radiation, and thereby we find them so bright in our sky. Here you can see in this solar image, you can also see the very dark solar spots, which is related to the magnetic activities of the sun. We learned about magnetism in the very first lecture, in the physics lecture. So here we are talking about the magnetic field of the stars. Next, we have the solar system, which are made of planets and sun. And all the planets orbit around the star, following the laws of gravity. One thing to note here is that not just the stars and planets, but the solar system consists of many other things, like we have the asteroid and the asteroid belts, we have the satellites orbiting around the planets. We have the occasional visitor comets which come in and visits our solar system, bringing in newer chemicals, newer elements, and so on and so forth. The stars themselves are not alone. They often occur in such open or globular clusters and gives us such very, very nice images. This happens because all the stars are formed in giant gas clouds where many, many, many stars gets formed at the same time, and all the nearby stars combine with each other to form this kind of collection through gravitational interactions, gravitational forces. And this kind of stellar cluster systems are wonderful to study because they gives us rich physics information about how the stars behave, how the stars of different masses behave, how the different elements are cooked in their hearts to see all the elements that we see on Earth, and how the stars interact with each other gravitationally. These stars are formed in this very, very nice gaseous cloud. It looks amazing, this kind of pictures, but they are not just nice pictures, but they also tell us information about stars are forming. Here you can see the very first stars getting born, and how even that this gives us clues about the formation of planets. So this looks very amazing. Now let's have some fun. Let's look at what happens when we play with this the stars. Now, unlike the very nice experiments we saw in the previous two talks, the problem with astronomy is we cannot do very nice big experiments in the lab because we are talking about stars, we are talking about planets that cannot be recreated very easily in the lab. So what we do is we create virtual experiments using computers and simulations. These computers and simulations are very detailed, implementing all the laws of physics, and that gives us an idea how the various astrophysical scenarios can be recreated and changed and played around with. For example, what happens when the star explodes, or what happens when two galaxies merge, and so on and so forth. So let's look at such an experiment. Sorry, is there any sound problem? Is anything audible?
Hello?
Hello?
Yeah, there's no audio, ma'am. No, ma'am.
Okay. Sorry about this. How about now? Is the audio okay?
Yeah, can you please? Yes, ma'am. It's okay.
Yeah, now it's okay.
Okay, thanks. Sorry, I will repeat a little bit.
If you just fast forward the time, the sun starts moving towards Betelgeuse. And now they look like they're in a collision course. We'll just zoom out of the scene. This results in a huge explosion that flings out matter from all sides. As you can see, we'll just rotate the scene around here a little bit so that we can focus on what's going on. As you can see, the matter is flung out from all sides at very high speed. Research suggests that our own galaxy, the Milky Way, and the Andromeda galaxy, which is also a nearby galaxy which is quite large, is supposed to collide with each other in about 4 billion years. So let's try to simulate that in our universe sandbox. So here we have two galaxies. The bottom one is the Milky Way galaxy and the upper galaxy is the Andromeda galaxy. So we'll just fast forward the time a little bit and see the dynamics of the collision of these two galaxies. So as you can see, this collision distorts both the galaxies. Initially, both of them were of spiral shape, but now it's totally distorted and there is no particular pattern that is visible here. So we can also play around with our own solar system. So here we can see that we have a solar system and the inner planets as well as the outer planets are quite visible, and in the middle we have the sun. So let's see what happens if we just remove the sun from here. So we'll fast forward the simulation. It's currently running at about 24 days per second. So as we can see, as soon as we remove the sun, the planets just fling out of their orbits tangentially. We'll fast forward this a bit and see how it looks. Okay, so just for fun, let's see what happens if we don't have a single moon around Earth, but have multiple moons. So as you can see, these moons, they collide with each other initially, and then they collide with the surface of the Earth. This totally destroys the surface, and all that's left behind is a giant fiery mess.
Wow, that was hello. Wow, that was really amazing. So using simulations, particularly the software universe in a sandbox, one can play around with this building blocks and gravity as well. So let's coming back to the building blocks. The next step in the building blocks is the galaxy, which we already have seen in the previous simulation. This is the Andromeda galaxy that was talked of in the simulation. And this is our neighbor. And here you can see that how amazing it looks. This galaxy contains about billions to trillions of stars. And the galaxies can come up in various shapes and sizes and also various morphologies. They can look very different. Here you can see some very irregular galaxy probably formed due to the merging scenarios that was also shown in the previous video, and the kind of spiral galaxy we see for the case of Milky Way. We'll learn about this more a little bit later. Now, hundreds and thousands of galaxies combine to form the galaxy cluster. These are the largest gravitationally bound objects in the universe. Here, each small speck that you are seeing is a galaxy. And this is the famous bullet clusters. In this particular cluster, two galaxy clusters, two collections of galaxy merged with each other. And that resulted in lots of collision of the gases that is present in the galaxy. And that's why we see them in this bright colors, because they get very, very hot. And not only that, these galaxy clusters are the ideal place to study presence of dark matter. We have probably heard of dark matter, which we cannot see any light from, but it interacts with the visible matter through forces of gravitation. So these galaxy clusters are the objects where dark matter is present in a large fraction. So once we study the galaxy clusters, we know how dark matter behaves and how much it is present in our entire universe. This is an amazing picture. This is about 1/10 this diameter of the moon that you see in the sky, this entire image. But this is one of the furthest and most deepest and the most sensitive image that of the universe that has been ever been taken. And each speck in this image is a particular galaxy. And you can see that not only there are different types of galaxies present, but there are many galaxies present if we can look further enough in the universe. So this tells us about the variety of galaxies in the universe, and not only that, about the cosmological history of the universe, what happened in the very early days of the universe. So this tells us about the formation history of the universe. This is all very nice, but what do we need to do to actually see these objects and learn about them? So the answer is obvious. We look at the light from them, or the electromagnetic spectrum. We learned a lot about light in Professor Sharma's talk. So as you see, that light can come in various forms and in various wavelengths. So we can look at the various radio waves, where the wavelengths or the length between each wave of that particular light is very large. In this case, the comparative pictures are given to show how large the wavelengths are. In the case of radio, the wavelength is order of the size of the buildings, whereas on the other end, we also have the gamma rays, where the wavelength of the incoming light is very small, close to the size of an atomic nuclei. And the human eye can only unfortunately see a small region, this shown by this Vibgyor color, of the entire electromagnetic spectrum, and all the sky we see by naked eye only shows light that is coming in this range. So that is all the optical telescope that we see at using the optical telescope. So let's look at the optical telescope that we have at IIT Indore.
For thousands of years, astronomy has been all about looking at the heavens above with the naked eye. Only after the invention of the telescope in the early 17th century was the field revolutionized. The new optical instrument was used to look at faraway objects as if they were nearby. Fast forward about 400 years, we have a diverse category of instruments whose optics range from as big as a school bus to as small as a matchbox. We at IIT Indore have few of these telescopes. These are two of them. Any telescope has two basic parts: the optics, which gathers the light, and the mount, which holds the full structure and is responsible for the movement. Further, depending upon the optics, a telescope can be of two types: a refracting telescope and a reflecting telescope. The major difference is that a reflecting one has mirrors, whereas a refracting telescope has lenses. If you slice open this telescope, this is what the path of the light will look like. Refracting telescopes typically have a lens at the front, a long tube, then an eyepiece at the rear, from where we can observe. Whereas a reflecting telescope uses a combination of mirrors or a single mirror that reflects light and form an image as shown here. Apart from the optics, the mount which holds the telescope can also be of different kinds. The mount, as you can see, helps to hold the telescope as well as to move it. The kind of mount that our telescopes have allows it to move in the altitude, that is this direction, as well as the azimuth, that is this direction. So this is called an altitude azimuth mount, or an on-azimuth. Now let's take this outside and have a look at some of the interesting objects. Now we see that this telescope is pointing towards an object that is called Orion Nebula, and it is found in the constellation of Orion. To locate an object in the sky, we have to move the telescope in altitude and azimuth direction that I already explained. But you see that this telescope is manually handled. But there are also other motorized telescopes. Let's go and have a look there. Now this is a motorized telescope. It is powered by an external source. which helps the motor to move this whole telescope. We can then use a remote control like this to move the telescope in the desired direction using the azimuth and the altitude controls. This is now pointed towards the Orion Nebula. You can come and have a look. Most of us, when we hear of astronomy, we think of looking at stars and galaxies at night because the sun is too bright during the day. Fun fact, we can look at everything even during the day using different kinds of telescopes at different wavelengths. Or we can send our telescopes to the space, like Hubble. Not only that, we can also use a solar filter on our telescope to look at the sun.
Oh, wow, that was very nice. And here is the image taken of the sun by our own telescope. And here you can see the sunspots when we pointed our telescope to the sun. So this is indeed very, very exciting. But that's all great. But what about the other regions of the electromagnetic spectrum? What about those regions? What about looking at the objects in those wavelengths? So to give that example, I always like talking about this nice experiment. Imagine an elephant, and there is a group of people who cannot see are touching this elephant and trying to predict what that object is. Now imagine whoever is touching the task will infer it to be a spear. Whoever is touching the elephant's ear will infer it to be a fan. So in the end, they will end up constructing such a strange object, each individual one of them. So astronomical objects are also a little bit like that if you are looking at one wavelength. So in order to understand what actually they look like, we have to look at them using all wavelengths because the underlying physical mechanisms in most astronomical objects emit across all wavelengths. So let's play a game. Let's look at these 4 images and try to infer which one of them is a galaxy or which one of them are galaxies. So try to answer this question here and keep your answer in your mind. We will give the answer in the next slide. Okay, I hope you have decided. The answer is all of them are galaxies, and not only that, they are images of the same galaxy. This just is how they look at different wavelengths: optical, infrared, radio, and X-rays. So this basically gives us an idea about the same object, how it can look very different in different wavelengths. And when we combine together, this is the how the total galaxy or the elephant will look like, giving information about various physical processes going on inside such galaxy. Apart from optical, particularly of interest is the radio wavelength because we can do radio observations from ground. Earth's atmosphere is transparent to radio waves, unlike any other wavelengths apart from optical. And so we can place our radio telescopes on ground and we can have a look at the sky through such radio telescope. In various wavelengths, this is the kind of facilities that we can use to look at astronomical objects in multi-wavelength. These are particularly the telescopes that India has developed. For example, you can see the AstroSat, which looks at the sky in X-ray and optical. The Aditya L1, which is just about to be launched, it will look at the sun in optical, UV, and X-rays. Then we have the very world-famous telescope facility, GMRT in Pune, which looks at the sky in radio. And in Ladakh, we have the very highly sensitive optical astronomy observatory. So we can use all of them to make a multi-wavelength image of the sky. That's all well and good. So how does the galaxy look in the radio band? This is a very nice image of a radio image of a galaxy in the radio wavelengths, and this is created by one of our students, Sarvesh. And here you can see the jet lobes, the jet emissions that comes from the radio galaxies. If you look further into the history of the universe and take a total radio map of the sky, this is how the radio map will look like, how the sky would look like in the radio wavelength. And all these bright patches that you see are the intensity of radiation in radio wavelengths that is coming from very early times in the history of the universe, just following the Big Bang. So radio provides insight into the physics of the universe, which was not present before. And using this, we can understand various underlying physics that is going on, or the evolution history of the cosmos. So let's look at the radio telescope that we have in IIT Indore. We are developing a radio telescope with this in mind, and have a look at our own.
In the lecture, we heard about the electromagnetic spectrum, which consists of multiple wavelengths all the way from. In the lecture, we heard about the electromagnetic spectrum, which consists of multiple wavelengths all the way from radio to gamma rays. So we can look at the universe at any of these wavelengths. Till now, we have learned about looking at the universe in the visible sky. But at IIT Indore, we also have telescopes through which we can look at the universe in the radio frequency. Most of us are familiar with the radio because of the FM that we listen to, the Wi-Fi, the ham radio through which we can connect with the people wirelessly around the world without the internet. So because of such long wavelengths, we also require a bigger telescope to look at the object at this frequency. Some of the interesting characteristics of radio are they can easily transmit through air and they reach us. They do not cause any damage to humans. And also, many of the interesting and fascinating astrophysical phenomena can be observed at this frequency. Now, let us have a look at the radio telescope we have at IIT Indore. Each antenna consists of three major parts: the control system, the dish, and the feed. The antenna control system moves the dish in the direction of source. The dish reflects the radio waves towards its focal point where the feed is located. The feed collects these waves and converts them to electrical signals. From the feed, the signal is passed on to the front end where it is amplified. The same process happens at all the antennas. Finally, the signal from each antenna is combined, amplified, and digitized at the back end. The entire arrangement of antennas is called as interferometer. Here we have 4 antennas, but in principle, we can have any number. After getting the data from the interferometer, we use various software and codes to study the source and try to understand the physics that is happening millions of light years away from us.
Wow, that was really cool. But I think you have seen this very famous, the direct image of a black hole, which was released a couple of years back. This image of a black hole was observed from this galaxy on the left. Now, such image was obtained by using interferometer, which you heard in the previous video. So what interferometer does, it combines not just the data from one telescope, but it combines the data, the images from various telescopes across, not just across in one site, but across the entire globe to make such a very nice image of the black hole that we have seen. So with deeper understanding of the universe, we need more and more better images, and that can not only be done by one telescope or a couple of telescopes at the same site, but we may need to make images by combining telescope all across the globe, which was done for the Event Horizon Telescope, which gave the image on the previous slide. And for the Event Horizon Telescope, it combined images from all these telescopes that you see at the bottom, and that works with the principle of interferometry that the student described in the previous video. Now, to acquire deeper understanding of the physics, we need bigger and bigger and better images and more detailed map of the sky. With this goal in mind, astronomers are developing novel and very highly sensitive telescopes across all wavelength bands. Here we are showing 3 major such big telescopes: the square kilometer array in the radio, the 30-meter telescope in the optical, and even beyond that, the LIGO, the Gravitational Waves Observatory in the gravitational wave band, which India is actually important. This is the 3 major astronomical mega projects that is taken up by the government of India. And this covers the entire electromagnetic spectrum band, and we can look at the objects all across the EM wavelength using this highly sensitive telescope, and beyond that in the realm of the gravitational waves. This is resulting in multiple scannings of the large portions of the sky by this telescope, resulting in many terabytes of exciting scientific cutting edge data. So what can you do? How can you contribute? So many highly sensitive telescopes across the world are giving rise to large volume of images and scientific maps of the sky. Many exciting science results are hidden in such images, just waiting to be discovered. And of course, you can join some scientific projects on that, but you can just start contributing right now, sitting at your home through the several citizen science projects developed. So our students will be talking about two such citizen science projects where you can contribute right now. So over to you, Aishila and Sharna.
Hello, ma'am. Am I audible?
Yes.
Okay, I'll just share my screen. Is it visible?
Yes.
Yeah. So, hi everyone. I'm Shwarna, and now I'll talk about one of the interesting projects that Zooniverse has. This project is based on spiral galaxies. So, before moving further, we need to know what are the different types of galaxies. So, the first one is the elliptical galaxy. They have a very smooth structure and ellipsoidal structure. They are also the oldest ones. The next one is the spiral galaxies. These galaxies have a very dense region at the center, which is called the bulge, and the extending spiral arms from the center. The third one is the irregular galaxies. These galaxies do not have any particular shape like the other two. So our focus will be on this spiral galaxy. There are two types of spiral galaxies. One is the regular spiral galaxies, like this one. Another is the barred spiral galaxies. So in this case, as we can see, there is a bar-like structure at the center. Also, this how tightly these spirals are wrapped defines a quantity called the pitch angle. And if these spirals are wrapped very tightly, the pitch angle will be small. And if the spirals are wrapped loosely, then the pitch angle will be large. Now, you will be thinking, why do we even need this? That's because human brain can identify patterns in much faster and better way than any computer algorithm. Also, by tracing these spiral arms, so in our project, we need to trace these spiral arms. And by tracing these spiral arms and knowing the pitch angle, some very interesting quantities like the mass of the central black hole, which is thought to be present at the center of each of these galaxies, can be estimated in easier way. Last year, Nobel Prize was also given for the discovery of such black hole in our own galaxy, that is the Milky Way. And also the stellar masses and the stellar formation and evolution histories also can be estimated in easier way by knowing this pitch angle. So how does this project work? You need to trace the spiral arms of a galaxy that will be given. So suppose 10 people are observing a galaxy and tracing the spiral arms. So at the end, taking all the resultant of all these tracings, a model image is made of the galaxy. And this model image, as you can see in this picture, is used for further scientific work. I'll just now show you how you can take part in this project. So you just need to Google Zooniverse and then go to their website. So here we will see all projects and then scroll down, and this you can see all the projects from different fields. We are interested in space, so I'll click there. And now, so this is the project we are now going to talk about. So I'll just get started. Yeah. So now this is a sky map, and you are only interested in the galaxy at the very center of this grid. So what you can do is you can zoom in clicking this button to see it more accurately, and also you can invert the color. Yeah. So as we can see, this galaxy has spiral patterns. And also this is not merging with this is also not merging with any other galaxies. So there are two options, and we will click on this option that this has a structure and it is not merging. Click next. Now what you need to do is you need to trace the spiral arms. So I'll just trace the spiral arm on left clicking the mouse. You just need to be a little bit careful while tracing the arms, because these are the real images taken by the real sky images taken by some big sky surveys like the Sloan Digital Sky Survey and the Dark Energy Camera Legacy Survey. And you are one of the first ones who will be analyzing this data and observing this galaxy. And by tracing these arms, depending on how you trace the arms, the model image will be made. And also from some previous universe projects, some really good discoveries have been done. So by your contribution can also be part of some major results in the future. And also I need to tell one thing, that you should not include this central bulge, or if there is any bar-like pattern at the center while tracing the spiral arms. And for further help, you can always see this tutorial. Now, as these arms are traced, so I'll click on done. And that's it. I hope you find it interesting. And you try this at home. So I'll now hand it over to Ashila. She'll show you some other Zooniverse project. Thank you.
Thank you, Swarna. Hi everyone, I'm Ashrila. And so now that you have seen some interesting projects that are that represent the far reaches of the cosmos, let's come a bit closer home to our very own red neighbor, Mars. And as you may know, the Mars is a very interesting and a curious planet. And for years, various space agencies from the Earth, including our very own ISRO, have sent many missions to Mars to understand what the planet is like. So as you can see from these schematics, there are many differences between our planet and the Mars. And so we need such missions to the planet to understand how it is similar to our own planet and how it can be different from ours. Like there are two kinds of missions that can go to Mars. One is an orbiter mission. What those things do is that the probes that they send from the Earth, they travel to the Mars and keep orbiting the planet and take pictures from above, which they send back to the Earth so that the scientists can analyze and investigate what is happening. Also, there are missions called the rovers and landers, like the Perseverance, that, as you may be aware, landed very recently in Mars and will very soon start sending us science quality pictures. Now, this interesting image was taken by one of the orbiters as this rover was landing on the surface of the Mars. Now, in order to analyze these images that the various missions have already sent back, we need your help. We need volunteers from citizens who may not necessarily be scientists in the real sense of the term, but whose contributions are very important for running projects like this. And so one of such projects is known as the Planet for Terrains. So in this case, how you get to the project is, as you have already been shown, you click on space in the Zooniverse page, and voila, this is your project. So what do you need to do for this project? This project consists of pictures that cameras from the context camera called the context camera aboard the Mars Reconnaissance Orbiter that has been orbiting the Mars has sent back to the Earth. Now, as the name suggests, this provides context for better observations. What kind of context are we talking about? These images are the images of the Martian South Pole. Now, as we know, the Earth's South Pole is covered by a layer of water ice. Similarly, the Martian South Pole has a layer of ice. The difference being that is carbon dioxide ice. And now during winter, obviously the ice freezes over, and during the Martian summer years, the sun thaws the ice, and various different types of features which are not like something that we see on our own planet become visible. What are the various type of features that you can see? I will now show. As you can see in this tutorial, this is your mission. You have to classify those images according to the features that you see.
What are the features? Spiders. As the name suggests, and as you can see in this image, they look exactly like some creepy crawly type spiders with a bulge like center portion and some legs that go around. And then these dotted structures, they are calling this as baby spiders, basically spiders that have no legs. And then another feature that they are saying is channel network. What is the channel network? It kind of looks like what our Earth looks like during summer when it gets dry and cracks up. So they are calling this as channel network. And Swiss cheese terrain, some kind of depression like structures on the surface that look like some cheesy structure. And finally, craters. We get craters on Earth as well, and they are basically formed by when some object impacts the surface of Mars and produces a bowl-like cavity. So now that you know what kind of landforms you need to classify, and then you might ask that, okay, I will classify these landforms, but why is this important? This is important because when you classify these images, it helps the scientists determine if there is any portion of the planet that has interesting potential of better scientific investigation. So they will identify that region from the images that you classify and send out better instruments to make measurements and take photographs. Also, you should remember that there are many images here that you as the citizen classifier will be the first person to see. So your classifications will go a long way in actually determining whether or not a particular area will be further investigated or not. So now that we have learned the context of why this is important, and also once again this needs to be done very carefully, because it's important that the classifications that go into the final images are as accurate as possible. So now that you are ready to do, let's go. As you can see, this image that has popped up, it has the baby spider like structures that I have shown you previously. So the task you have to do is very, very simple. You just click on baby spiders and you're done. So now you go next, and then your next image will pop up. And as you can see in this image, there are no discernible features that you see. Always remember that if you're unsure whether any feature is present or not, you click on none of the above features are present, because clicking this is better than misclassifying, because that ultimately leads to some mistakes being made, and we do not want that. So this was another citizen science project that you can try your hands in. And so if you have enjoyed classifying the spiral galaxies using the project my colleague mentioned and our very own red planet, you can go to the Zooniverse webpage, and there are many, many more interesting projects that you can try out. Unfortunately, we can't show all of them to you, but the links will be available for you to try out in the chat. So do go and try out some real ones, where the Radio Galaxy Zoo, as you can see, I have listed here. What it does is it tells you to classify galaxies as we see them in radio light, as was already mentioned by Manonita. Also, Backyard Worlds Planet 9, because let's face it, we have demoted Pluto and we really need another planet. So we are looking for potential candidates for the 9th planet. And Gravity Spy. LIGO data, our very own gravitational wave observatory data. They will give you the data and tell you to see whether you can see any feature that they want you to see that will help them classify gravitational waves. So that was all from our end, and we hope you enjoyed our talks, and have a very nice day, and happy classifying and contributing to science. Thank you.
So that was such a spectacular description, and wonderful to watch all the heavy objects under the farm. And I can't thank you enough for giving this talk, this amazing presentation. And thank you once again. Please, sir.
चांद तारों की यात्रा कराए, कुछ क्षण आसमां में बिताए, कहीं सूरज, कहीं चंद्रमा, कहीं तारों की व्याख्या। एस्ट्रो है विज्ञान की अप्रतिम आभा। Thank you so much, ma'am. Really, it was a wonderful journey of universe by virtual track. Thank you so much. अब तक हमने देखा फिजिक्स, केमिस्ट्री एंड एस्ट्रो से जुड़े अद्भुत प्रयोगों को। आइए अब हम चलते हैं गणित अर्थात मैथमेटिक्स के कुछ प्रयोगों की ओर। So I would like to welcome Mr. Aniruddha Desmukh for demonstration of real mathematical model. Please welcome Mr. Aniruddha Desmukh.
थैंक यू। सो तो जैसे अभी इन्होंने बताया, अभी तक हमने फिजिक्स, केमिस्ट्री और एस्ट्रोफिजिक्स के बारे में थोड़ा सा जाना। अब हम जानना चाहते हैं कि मैथमेटिक्स में एग्जैक्टली क्या होता है। सो स्कूल लेवल पे यूजुअली मैथमेटिक्स बहुत ज्यादा फॉर्मूला बेस्ड होता है, राइट। सो कुछ गिवन चीज होती है, जैसे ए प्लस बी होता है, स्क्वायर लेना है तो उसका कुछ फॉर्मूला होगा। कोई शेप है, उसका सरफेस एरिया फाइंड करना है, उसका कुछ फॉर्मूला होगा। सो हमने कोशिश ये की है, ये सारे फॉर्मूला आते कैसे हैं, इसको दिखाने के लिए कुछ मॉडल्स है हमारे पास। तो क्योंकि अब देखी हुई चीजें ज्यादा अच्छे से याद रहती है और ज्यादा अच्छे से समझ पाते हैं, तो अब हम वो सारी चीजें देखेंगे। तो ये सारी चीजें हम 3 पार्ट में करेंगे। पहले पार्ट में मैं कुछ मॉडल समझाऊंगा, स्पेशली ट्राइनोमियल एक्सपेंशन की, यानी कि a प्लस बी प्लस सी होल स्क्वायर कैसे पाया जाए उसके बारे में देखेंगे। फिर हम जाएंगे कोऑर्डिनेट ज्योमेट्री पे, जो कि 3 डायमेंशनल ज्योमेट्री होती है। तो उसमें हम देखेंगे एक्स वाई जेड एक्सिस कैसे होते हैं, किस तरीके से स्पेस हमारी बनती है, और फिर 3 डायमेंशनल ऑब्जेक्ट्स भी क्या होते हैं। तो कुछ ऑब्जेक्ट जो हम देखेंगे वो भी क्यूब, क्यूबॉइड और सिलेंडर, कोन, पिरामिड एक्सेट्रा। ये सब स्कूल लेवल पे यूजुअली हम देखते हैं। और फिर लास्ट में मैं एक और चीज के बारे में बात करूंगा, दैट इज कॉल्ड द टावर ऑफ हैनोई। सो वो एक कॉम्बिनेटरिक्स की प्रॉब्लम है, वो हम देखेंगे उसमें पूरा एक्सप्लेनेशन के साथ। और उसके बाद अनुश्री गुप्ता, एमएससी स्टूडेंट, आपको एक्सप्लेन करेंगे पाइथागोरस थ्योरम को किस तरीके से विजुलाइज किया जाए। तो पाइथागोरस थ्योरम तो सबको पता होगा कि अगर हमारे पास एक राइट एंगल ट्रायंगल है और उसके साइड्स है ए बी सी, तो हाइपोटेन्यूज अगर सी हो तो सी स्क्वायर इज इक्वल टू ए स्क्वायर प्लस बी स्क्वायर। सो इसको हम देखेंगे ज्योमेट्रिकली और रादर विजुअलाइजेशन करेंगे उसका किस तरह से वो आता है। और फिर फाइनली हमारे फैकल्टी मेंबर विवेकानंद सर आपको कुछ मैथमेटिक्स के फॉर्मूले के बारे में बताएंगे कि किस तरीके से फॉर्मूले इसको ड्राइव किया जाए। सो लेट अस स्टार्ट।
So now we will look at the trinomial expansion. That means you have 3 numbers a, b and c. You have to add them and then you have to square them. So that means we have to form a square of side length a plus b plus c and then know how many of these unit squares, the smaller squares, can be fit inside whole of this square, the bigger square. So let us try to see the side length first. Each side of this square is composed of 3 numbers a, b and c. So definitely I can fit a square of area a square inside this bigger square. So I have this square fits very nicely, that is fine. Then I also have a number b which comprises the side length. So there should be a square of side length b which can be fit inside this bigger square. So there is this b square as well, and then corresponding to the number c we have another square of area c square which fits inside this bigger square. Now there are certain rectangles that remain, so let us look at those rectangles. One of the rectangle has side b plus c and the other side is a, so that area would be a times b plus c. So a times b plus c. There is another rectangle of this sort. It is over here. One of the sides is b plus c, the other side is a. So the area would be a times b plus c. Now still there are 2 rectangles that remain. Each rectangle has one side as b and the other side as c. So their area would be b times c. B times. So how many total tiles have we put inside this bigger square? We have put a square tiles first, then b square tiles, then c square tiles, and followed by a times b plus c tiles, then that is 2 times. Similarly b times c tiles, again 2 times. So what is a plus b plus c whole square? It would be a square plus b square plus c square plus 2 times bc plus 2 times A times B plus C. So hello, now let us look at the three-dimensional space that forms the basis of three-dimensional geometry. So there are total 3 axes which you can see. The one is the x-axis, the other is the y-axis, and the third one is the z-axis, which is the vertical one. Now these horizontal axes, x and y, they together form a plane, this orange plane here. This is called the xy plane. This green plane contains x-axis and z-axis. So this green plane is called the xz plane. And this pink plane contains the y-axis and the z-axis. So it is called the yz plane. Now all these planes, they intersect at a certain point, which is called the origin of our coordinate system, and usually denoted by 0, 0, 0. And all these planes which we have seen, they divide this whole three-dimensional space into 8 parts. The first part, which contains x, y and z, all positive, it is called the first octant. All of these are called octants, but each octant differs from the other from a sign of one of these axes. So the first octant has positive x, positive y and positive z. The second octant has negative x, positive y and positive z. The third octant has negative x, so third octant is over here. It has negative x, negative y but positive z. The fourth octant, which is here, has positive x, negative y and positive z. And the other 4 octants are on the other side of xy plane. So the fifth octant here, this would have, so let us see, the first octant contained xy positive. So the fifth octant would contain xy positive, but now I have reversed the z axis. So now x is positive, y is positive, but now z is negative. Similarly, now sixth octant, the second contained negative x, positive y and positive z. So the sixth will contain negative x, positive y and negative z. Then the seventh octant will be below the third octant. So it will contain negative x, negative y, but then also negative z. And the eighth octant, which is below the fourth octant, will contain negative y, positive x and negative z. So now we will look at some three-dimensional geometric shapes and we will try to know how to find their surface area. So the basic shape is a cube. So how is a cube formed? So just take some side length A and you take, so there are 6 possible squares. So let us try to form a cube. So now as you can see, there are 6 squares here. So 1, 2, 3, 4, 5 and 6. So to form a cube, I am going to sort of glue this thing on one on the other so that I get a closed surface. That means the surface of a cube. So I have this, and then all those 6 squares together, they give me completely this cube. So what will be the surface area of this? Look at any square, take its surface area, take its area. That area would be A square. So if the side length is A, this area is A square. And there are 6 possible squares here. So total surface area of the cube is 6 times A square. The next simple three-dimensional object is a cuboid. So here as you can see, this is not exactly formed by squares, but there are some certain faces which are rectangles as well. So this one is a square, and similarly the opposite one is a square, but all other faces are rectangles. So how to form that? So this is a cuboid and it is formed by 2 squares. So these 2 blue things, these are squares, and then there are 4 rectangles, the yellow ones and the red ones. So what is the total surface area of this cuboid? It would be the surface, the area of the 2 squares, which would be A square plus A square, and then the area of these 4 rectangles. So since this rectangle shares a common side to the square, one of its side length is A and the other side length maybe it is B. So what is the area of this particular rectangle? This yellow rectangle? It is A times B. So there are 4 such rectangles. So the total area by this rectangles is 4 times A times B. And there are 2 squares, each of side A. So the total surface area of cuboid is 4AB plus A square. Now let us look at the cylinder. So a cylinder is formed by a rectangle. So this is a rectangle. You have to join the 2 sides of this rectangle. So I have joined these shorter sides actually. You can join the longer side as well, you will still get a cylinder. So once you join these shorter sides, you get a cylinder. And then there are 2, automatically once you join this, there are 2 circles that are formed, one on the top and one on the bottom. So if you want to find the surface area of this cylinder, how will you find it? Just look at this rectangle here. The area of this rectangle, it will be the length of this side and the length of this side. But what is the length of the shorter side? It is going to be the height of cylinder. So once you join these shorter sides, I get the height of cylinder. This is the shorter side of the rectangle. And what is the longer side? This is the circumference of this circle. So total area of this rectangle, it would be circumference of the circle which I get, that is 2 pi r into the height of this, so that is h. So area of this cylinder, other than these 2 circles which are formed, one at the top and one at the bottom, you can think of these as lids. So that would be 2 pi r. And then if you also consider these 2 circles, that would be pi r square each. So the total surface area of the cylinder would be 2 pi r h plus 2 pi r square. Then there are certain shapes such as pyramid. Now pyramids can be formed in 2 ways. Either you can have a square base like this one, and once you have a square base, you try to form triangles from those squares, and all these triangles will meet at certain point. That particular point is called the apex of this pyramid, and this base is the square base. So to find the area, it would be just the area of this triangle, all these 4 triangles, and an area of the base. So depending on what the sides are and what is this length of this side of a triangle, the formula for the area depends. The other sort of pyramid is a triangular base pyramid. That means now the base is a triangle, and then from each side of this base triangle, you try to form other triangles as well. So now there are total 4 triangles each, and the total surface area would be 4 times the area of one triangle. Hello. So let us look at a problem from combinatorics. That is, this is a tower, famously called as the Tower of Hanoi, and we want to shift this whole tower from the left hand side to the right hand side. But the condition is that when I shift this, I cannot put a bigger disk on a smaller disk. This is not allowed. So how many steps do I require to completely transfer this Hanoi tower from the left side to the right side? So let us start with a simple steps. Suppose I have only one disk. What can I do to transfer this from left side to right side? Just take this and put it on the right side. So total number of steps that I require is only 1. Now suppose I have 2 disks. How many total number of steps will I require? So now there are certain possibilities that can arise. Suppose I take this smaller disk and put it on the right side. Then what can I do? This bigger disk cannot go on the smaller one. So the only way I can transfer this is to transfer it to the center. But now actually I wanted this bigger disk to go on the right side. So I have to empty this right side first. So I have to empty this and I come back to the left side, and then, so these are 3 steps already done, and this is the 4th step, and then there is the 5th step. So I can transfer this tower containing only 2 levels from the left side, right side to the left side by using 5 steps. But then the question is, whether I can do this in a smaller number of steps. So the problem was that once I put this on the rightmost side, I cannot bring this to the rightmost side immediately. So instead of doing this, I will transfer this at the center. Now the only way I can transfer this is to make it to the right side. This is the second step, and in the third step, this goes here. So now let us see. So the minimum number of steps which I require is 3 for two towers containing 2 levels. So if we see, there is a pattern. When I had only one disk, I required 1 step, which is 2 to the power 1 minus 1. When I had 2 disks, I required 3 steps, which is 2 to the power 2 minus 1. So can we say that if I have 3 disks, I will require 2 to the power 3 minus 1, which is 7 steps. So let us see this. Now I know that these 2 disks can be shifted from one place to another using 3 steps, at most 3 steps. So instead of shifting this to the right hand side, I will shift this to the center. So how will I do it? So this is step 1, step 2, and then step 3. Now the next natural thing to do is take this largest disk and get it to the rightmost side. This is the 4th step. Then this is the 5th step, this is 6th step, and the 7th step, as we had assumed, as we wanted. Now suppose I have a bigger tower. How many number of steps will I require? So this contains 1, 2, 3, 4, 5, and 6 levels. So actually forming all of these steps will take a lot of time. So, but what do I know? I know that if I take a smaller section of it, it contains 5 levels. So I will require 2 to the power 5 minus 1 steps to bring this to the center. Then 2 to the power 5th step, that is the 32nd step, will bring the largest disk to the right hand side. And then I will require another 31 steps to bring this smaller tower from the center to the right. So how many total number of steps did I require? 2 to the power 5 minus 1 plus 1 plus 2 to the power 5 minus 1. That is 2 to the power 6 minus 1. Similarly, you can have for, say you have n number of levels, then for n minus 1 you will require 2 to the power n minus 1 steps, and then you bring this largest disk to the right hand side, 1 step gone, so that is 2 to the power n minus 1 steps, and then again 2 to the power n minus 1 steps, that would be 2 to the power n minus 1 total steps.
So जो लास्ट में हमने देखा उसे यूजुअली कहते हैं प्रिंसिपल ऑफ मैथमेटिकल इंडक्शन. सो दैट मींस दैट अगर हमें पता हो कि से n के लिए हम किस तरीके से कुछ फार्मूला बना पा रहे हैं, तो क्या n+1 के लिए भी हम उसी तरह का कोई फार्मूला बना पाएंगे? सो वो आगे जाके बहुत यूज होता है. सो वन ऑफ द एप्लीकेशंस ऑफ दिस मैथमेटिकल इंडक्शन इज दिस पावर ऑफ. So now we have the video by Anushree Gupta on the Pythagoras theorem. So let me just share it.
Hello everyone, let's have a look at a famous theorem by Pythagoras. He was not only a great mathematician, but also he has immense contribution in various fields like physics, astronomy. So this is Pythagoras theorem. What does this theorem states? The theorem is widely used tool in geometry. It states that perpendicular square plus base square equals to hypotenuse. So this side is base, this is perpendicular height, and this side opposite to the right angle is hypotenuse. The theorem holds for a right angle triangle. Let us try to visualize it. Let us take this triangle and I take 3 squares of different size, 1, 2, 3. Arrange these squares in the manner like this. Now this square has side P, so its area is P square. And this square has side B, so its area is B square. While the big one has the area H square. So from the theorem, we have that p square plus b square equals to h square. So this means the sum of the area of this square and this square is equal to the area of this square. Well, that means that these two squares should fit into this square. But how do we do that? Like this. So let's try doing it. Let's cut these squares into pieces so that we can try fitting in it. So this square is 3 cross 3, so 9 pieces I cut. And for this one, 4 cross 4, 16, so 16 pieces. Now let us try to fix them in this big square. Egyptians were using this theorem way before Pythagoras has stated it officially. See, this fits too well. So hence, it is verified. You can also prove this in many different ways. So now let us look at the applications, how we use this theorem in our daily life. For example, you can use it for sea navigation. Suppose this is a sea and this is your ship. You are asked to travel 300 miles to the north and then 400 miles to the east to reach your destination. So, using this theorem, what you can do is we can compute this distance. Like p square plus b square equals to h square. So this distance comes out to be 500 miles. Also, this angle can be computed. So this was the one use which you can. Also, in the similar manner, you can use it for air navigation, construction of ramps, buildings. So this theorem has a wide importance in daily life and practices. Thank you.
Oh. So now we have a presentation by our faculty member, Dr. Vivekanand Maji. So I'll just start with this. So he will be telling us about certain formulae which we come across in mathematics and how to get them. Also their importance. So let us see.
Good afternoon, everyone. I hope all of you are enjoying today's event. So just now you have seen some beautiful models, mathematical models. Now in this talk, I'm going to explain a few more beautiful formulas in mathematics. So first I'll talk about sum of n consecutive natural numbers. So here is the picture of Carl Friedrich Gauss. He was a German mathematician and physicist who had contributed many significant contributions in mathematics. So let me begin with this story. One day, Gauss' teacher asked his student to add all the natural numbers from 1 to 100. He thought this task will take time. But he was surprised when young Gauss found the answer within a few minutes. And the answer is 5050. Now, how he did it? So we are basically interested to find this sum. So let's see. So first we write the sum S equals to 1 plus 2 plus 3 up to 100. Again, we write the same sum in the reverse order, 100 plus 99 plus 98 and so on up to 1. Then if we add these two lines, so in the left hand side, we'll have s plus 2s, and in the right hand side, you see 1 plus 100 is 101, 2 plus 99 is also 101, 3 plus 98 is also 101, and so on. Every time you are getting 101, how many times you will get? 100 times. So we have basically 2s equals to 101 times 100, and therefore s equals to 101 times 50, which is nothing but 5050. So it is very simple, right? Now, some of you may be thinking about what will be the value of this sum of natural number up to 10,000. So we can do this sum exactly the same way Gauss did. More generally, we can find a formula for sum of natural numbers up to n, where n can be any given number. N can be 1 crore, n can be 10 lakh, anything. So how we have to do? We are trying to find a formula for this, right? So we write again same way, s equals to 1 plus 2 plus 3 up to n. Again we write the s equals to in the reverse order. Then we sum these two lines. Therefore we'll get 2s equals to n plus 1 times n, and therefore s equals to n times n plus 1 by 2. So this is the formula for sum of the natural numbers from 1 to n. So if you know this formula, then to calculate this kind of sum, it is very easy. But if you don't know this formula, then it may take really long time. Okay, now some of you might be wondering about, we have seen the sum of the natural numbers. Now, what will happen if we consider the sum of the squares? Like 1 square plus 2 square plus 3 square and so on up to 100 square. Now, we cannot use here Gauss technique, because 1 square plus 100 square is not same as 2 square plus 99 square. So in this case, we have to find a new technique. So more generally, we can try to find a formula for one sum of the square up to n square, where n can be any natural number. So let's see. Okay, so we are interested to find formula for sum of the squares, but we are beginning with this sum where I plus 1 cube minus I cube, I is running from 1 to n. So for I equals to 1, this is nothing but 2 cube minus 1 cube. For I equals to 2, it is 3 cube minus 2 cube. Now this is a telescopic sum, and you can see that this 2 cube and here minus 2 cube, so they are getting cancelled. So finally what we'll have, n plus 1 cube minus 1 will remain. So this is nothing but n cube plus 3n square plus 3n. Again we write the same left hand side expression. Here we are doing the calculation in a little bit different way. So first here we are using I plus 1 whole cube. Here we are using a plus b whole cube formula. So I cube plus 3i square plus 3i plus 1 minus I cube. So this I cube is getting cancelled. So this thing is remaining. And this 3 times summation I square. Okay. So we are interested to find formula for this sum. And we already have seen that summation I from 1 to n, that is n times n into n plus 1 by 2. So now from equation 1 and equation 2, if we equate these two things, so and do little bit calculation, then you can prove that summation I cube from I is 1 to n, this is n into n plus 1 into 2n plus 1 by 6. So now you can put any value of n and you can evaluate the sum of squares. So if we put n equals to 100, then sum of squares up to 100 square will be 3,38,350. Now, after calculating the formulas for sum of the natural numbers, then sum of the squares, what will be the next natural question? What Is there any formula for sum of the cubes, or sum of the fourth powers, or sum of the 100 powers? Is it possible to obtain formulas for these kind of sum? Yes, Jacob Bernoulli, he was a Swiss mathematician. He proved that yes, it is possible to obtain formula for any kth power, where k can be any large natural number. K can be 1 lakh, k can be 10,000, k can be 1 crore, k can be anything. So still it is possible to obtain a formula for this kind of sum. Okay, now let me talk about binomial theorem. So all of you know this a plus b whole square is a square plus 2ab plus b square. So how to derive this formula? So a plus b whole square is nothing but a plus b times a plus b. And again, this is nothing but a times a plus b times a plus b. And you do little bit calculation and you can prove that a plus b whole square is a square plus 2ab plus b square. Similarly, we can derive that a plus b whole cube formula is this: a cube plus 3a square b plus 3ab square plus b cube. Now, natural question is that, is there any formula for a plus b whole to the power 4? Is there any formula for a plus b whole to the power 91? Or is there any formula for a plus b whole to the power 1000? Yes, it is possible to obtain for formula for a plus b whole to the power n for any natural number n. And the formula is this. So here the sum is running from k equals to 0 to n choose k, a to the power k times b to the power n minus k. And where n choose k is n factorial by k factorial times n minus k factorial. This is known as binomial theorem. Okay, now I'll talk about Pythagoras theorem. So Pythagoras was a Greek mathematician. You have already seen in the last presentation that Anusri has talked about this Pythagoras theorem. It's for any right angle triangle, this a square plus b square equals to c square. Okay, so by geometrically here, if you consider a square of size c, then the area of this square is c square, and area of square in this side it is b square, and the area of square with side a is a square. So the area of the bigger square is same as the sum of the area of two smaller square. So c square equals to a square plus b square. So you can check that 5 square equals to 3 square plus 4 square. 5 square is 25, 3 square is 9, and 4 square is 16. 25 is 9 plus 16. Similarly, you can check that 13 square, which is 169, is same as 5 square plus 12 square. 5 square is 25 and 12 square is 144. So 169 is 25 plus 144. So and so on. Now one question may come in your mind, how to find such solutions? How many such solutions exist? So interested students can check that this will be true, where this you can think this n square minus 1 is like a and b is like 2 times n and c is like n square plus 1. And therefore, you will have infinitely many positive integer solutions of this Pythagoras theorem. Now, can we find positive integer solutions of this equation, a cube plus b cube equals to c cube? Again, you can ask, can we find positive integer solutions of the equation a to the power 4 plus b to the power 4 equals to c to the power 4? More generally, one can ask, does there exist any positive integer solution such of this equation where n can be any natural number larger than equals to 3, like a to the power 100 plus b to the power 100 equals to c to the power 100. So this equation does have any non-zero positive integer solution. So can you find A, B, C such that a to the power 100 plus b to the power 100 equals to c to the power 100? Now, Pierre de Fermat, he was a French mathematician. He observed that in this line, observe to domine Petri de Fermat, so observation of Pierre de Fermat. So in this margin, he said that it is when n is bigger than equals to 3, you cannot find non-zero positive integers such that a to the power n plus b to the power n equals to c to the power n. However large n you consider, you will never find a, b, c positive integers such that this will hold. And he also mentioned that he knows the proof, but the margin is so small to contain the proof. Later also, he never gave a rigorous proof of his claim. So over the years, many mathematicians tried to prove this Fermat's last theorem, but couldn't succeed. Finally, after 358 years of effort by mathematicians, the first correct proof was given by Andrew Wiles in 1994. He worked on this theorem for 7 years in isolation. Here's the picture of Andrew Wiles. Now I'll end with this Bill's conjecture, which is still open. Like if one solves this problem, he will get $1 million prize. So $1 million is almost 7 crore rupees in Indian money. So Bill's conjecture is a generalization of Fermat's last theorem. It states that if greatest common divisor of ABC is 1, then for any positive integer m and n and p, so here the exponent in the Fermat's theorem, exponent m and p were equal. Here m and p can be anything, like m can be 3, n can be 4, p can be 5. So this kind of equation also, there is no such solution. You cannot find any solutions of this equation. So this conjecture was given by Andrew Bill. Andrew Bill, he is a banker in Texas. So he is a banker but amateur mathematician. He proposed this conjecture, and he also proposed this prize amount. So American Mathematical Society quoted that one of Andrew Bill's goal is to inspire young students to think about this equation and think about winning the offered prize, and in the process become more interested in the field of mathematics. So here is the picture of Andrew Bill. Thank you for your attention. Enjoy the day. If you have any questions, please feel free to ask me, and you can write to me. Here is my email ID. Thank you.
Wow, so it was really nice. I hope many of us will be now inspired to get $1 million prize after solving that theorem. So, okay. So, mathematics department ends the presentation here. We would like to thank a few people. One of them is my colleague, Dipen Pravani, who helped me record the videos and read them. And the other one is Mr. Banti Verma, who lent us the camera for our recordings. Without that, all this would not be possible. So, thank you.
Thank you so much, sir, for wonderful talk about formulas in mathematics. Thank you so much, Mr. Aniruddha Deshmukh and Ms. Anusri, for showing mathematical models with easy demonstration. Thank you so much. अब हम बढ़ते हैं विज्ञान की ऐसी शाखा की ओर जो सूक्ष्मतम संरचनाओं से दीर्घ संरचना तक और प्रोकैरियोटिक सेल से यूकैरियोटिक सेल तक जाती है। हम बात कर रहे हैं बायोलॉजी अर्थात जीव विज्ञान की। Now I would like to invite Mr. Sandeep Chaudhary from BSBE department. Please come and start the session of biology for school kids. Please welcome Mr. Sandeep Chaudhary.
Good afternoon to one and all. Thank you, Reena, for a kind introduction. So, आप लोगों ने फिजिक्स, केमिस्ट्री, एस्ट्रो सब चीज़ों के बारे में सुना, देखा, समझा। अब हम थोड़ी सी बायोलॉजी पढ़ते हैं। इसमें हम टोटल 4 मॉडल्स के बारे में बात करेंगे, जिसमें हमारा हमारा हार्ट कैसे काम करता है, उसकी पंपिंग एक्शन कैसी होती है। फिर हम बात करेंगे लंग्स के बारे में, क्योंकि कोरोना टाइम चल रहा है तो लंग्स के बारे में जानना ज़्यादा ज़रूरी है। हमारा लंग्स कैसे काम करता है, उसकी कैपेसिटी कितनी है, हम कितना इनहेल कर सकते हैं एक टाइम पे, उसका वर्किंग मॉडल हम पेश करेंगे। उसके बाद हम बात करेंगे मलेरिया के बारे में, कि मलेरिया क्या होता है, कैसे होता है, और उसको लैब में कैसे टेस्टिंग की जाती है। एंड देन वी विल फर्दर प्रोसीड फॉर डिटेक्शन ऑफ पेस्टिसाइड्स, कि फार्मर्स खेतों में पेस्टिसाइड यूज करते हैं, जिससे पानी, जो आसपास का पानी होता है, तालाब का पानी होता है, वो गंदा होता है और वो फिर साइकिल के थ्रू एनी हाउ हमारे ड्रिंकिंग वाटर में मिक्स हो जाता है। तो हम कैसे पेस्टिसाइड्स को डिटेक्ट करते हैं लैब में, उसके बारे में हम बात करेंगे। तो चलिए स्टार्ट करते हैं हम प्रेजेंटेशन, जिसमें हम बात करेंगे ह्यूमन हार्ट के बारे में।
Hello everyone, a warm welcome to one and all on the occasion of National Science Day. I am Sandeep Chaudhary, member of TheraSense Lab, supervised by Dr. Abhijit Joshi, BSB, IIT Indore. Today, I will demonstrate the working of human heart. Before we proceed, let's check some fact on our heart. Our heart is about same size as our fist. The heart beats on an average of 72 times per minute. That is our heart rate. An adult heart pumps approximately 5 to 6 liters of blood in a minute. It takes only about 20 seconds to pump blood to every cell in the body. So we can check our heart pulse or our pulse at our wrist below our thumb. Each beat is caused due to the contraction of the heart. So our heart has some responsibility, that is, it provides oxygen and nutrients to our cells to keep us alive. It also carries away waste from these active cells to special organ. So the blood is clean in the kidney. Now let's discuss the working of our heart, how our heart will work. Our heart consists of 4 chambers, mainly right atrium, right ventricle and left ventricle. So the blood comes into the heart from the body from superior vena cava and inferior vena cava to the right atrium. This blood is deoxygenated blood, means that is less in oxygen. Then from right atrium it goes to the right ventricle through the valves. From right ventricles through pulmonary arteries it goes to the lungs. In lungs the oxygenation of blood is happen, and from pulmonary veins it goes to the left atrium. Now this blood is rich in oxygen. So from oxygenated blood from left atrium goes to the left ventricle, and through aorta again it circulates throughout our body. So we will see the demonstration of working of our heart in the coming slide. Before that, to keep your heart in shape and healthy, we should do 15 to 20 minutes of exercise each day to so that our heart works well, and we should eat variety of healthy foods and avoid lot of fatty foods, junk foods. Stay away from smoking to keep our heart healthy and safe. Now let's go to the demonstration. Here we will demonstrate you the working model of heart. So for making this model, we need 3 water bottles, in which the center water bottle needs 2 straw size hole and a glue gum to fix this, and the left side bottle needs 1 straw size hole and the right side bottle needs 1 straw size hole. So by this, the left side bottle is known as your atrium. This works as a function of ventricle, and the green bottle is known as your body. So how it functions that the ventricle pumps the blood through the body. So blood comes to the atrium and it goes to ventricle, and then ventricle it goes to the body. So here we will see that this is wall, this is unidirectional wall. So we can see that the blood is coming to our body. From ventricle is coming to our body. So we can squeeze this wall and you can see that our blood from atrium it goes to the ventricles, and from ventricle it goes to the body. So this is the overall working model of our heart. Thank you. सो इस तरह से हम हार्ट का वर्किंग मॉडल अपने घर पे बना सकते हैं, जिसमें हमें मेनली 3 वाटर बोतल चाहिए, जिसमें हमें एक बोतल पे 2 छेद करने हैं स्ट्रो, जिसमें हम स्ट्रो डाल सकें, और एक बोतल में एक ही छेद करना है जिसमें एक स्ट्रो डालनी है। इस तरह से हम घर पे कैसे हार्ट वर्क करता है उसको हम डेमोन्स्ट्रेट कर सकते हैं। चलिए अब हम अगले डेमोन्स्ट्रेशन की तरफ मूव करते हैं, जिसमें हम बात करेंगे लंग्स के बारे में, जिसमें हम जानेंगे कि हमारा लंग्स कैसे काम करता है और लंग्स की कैपेसिटी को हम कैसे घर पे चेक कर सकते हैं। ये हम सब अपने घर पे ट्राई कर सकते हैं। बहुत ही सरल और सस्ता तरीका है अपनी लंग्स कैपेसिटी को चेक करने के लिए। लेट्स सी इन द प्रेजेंटेशन।
Hi friends, this is Neha and I am here to have a small talk on lungs and its capacity. It's considered that more the lung capacity is, more healthier are your lungs. But before going to lungs and its capacity, let's have a small chit chat. So what's the one thing you do all day, every day, everywhere, with whomsoever you are, wheresoever you are, whether you are having some fun, you are eating, talking, playing, bathing, meditating, sleeping, whatsoever you are doing? Any guesses? It's breathing. Yes, you always inhale the air and exhale the air. This inhaling and exhaling process is known as breathing. Have you ever felt that you have stopped breathing? No, because you don't. It's necessary for a human to breathe. We can die within minutes if we stop breathing. So, when it comes to breathing, who's in charge of it? They are lungs. Yes, they are the largest organ of our body. Each and every individual have 2 lungs, one on the left side of the body and another on the right side of it. Have you ever wondered what makes up the lungs? Have you ever thought about it? They are made up of very small air pouches, and this air pouch are known as alveoli. This is the place where the blood mixes up with the air. And this is what happens when you inhale the air and exhale the air. When the air is inhaled, the chest is expanded, while when it is exhaled, the chest is compressed. Now, one of an amazing fact about lungs is, believe it or not, you take around 23,000 breaths each day. You can count it if you don't believe me. Now, coming to lung capacity, what does it mean? It's simply, in a very simple way, it means the maximum amount of air that your lungs can hold. Now, on an average, a human being's lungs breathe in around 1.4 liters of air every minute and around 11,000 liters of air on every day. That's a fact.
Today, I am here to demonstrate via a very simple experiment how much amount of air my lungs can hold. And this particular thing will give me what is my lung capacity. It's a very simple experiment and I require a bottle, a tray and a small pipe. I have this particular bottle which has a capacity of 5 liters. I have filled the water till the brim so that no air space should be left. Now, what I'll do is, very cautiously, I'll take this bottle, invert it, and keep it in the tray. Do it very carefully so that the water does not leak out. Now, take the pipe, insert it in the mouth of the bottle very carefully, and now the fun begins. What you have to do is, you have to simply inhale the air as much as you can, and then exhale the air with the help of this pipe, like this. Have you seen what happened? When I pour the air, when I exhale the air, the water in the bottle just came up, and now you can check what's the level of water right now. It's 5,000, 500, 1,000, 150, 100, and then comes 2,000. That means my lung capacity is 2,000, which is one of an average human lung capacity. So it's a very simple experiment. You can try at home. You can just check the lung capacity of yours, your friends, your family. Have fun.
तो हमने देखा नेहा ने कितने आसान तरीके से अपनी लंग्स कैपेसिटी को बताया। इसी तरह हम अपनी लंग्स कैपेसिटी रोज, महीने में, हफ्ते में, कभी भी कहीं पे भी अपने घरों में चेक कर सकते हैं। इसी के बीच में मुझे एक ख्याल आया कि जब क्लिनिकल डेथ होती है, जब कोई भी इंसान ओल्ड एज जब मरते हैं, तो लंग जब हम कंपेयर करें 3 ऑर्गन के बारे में बॉडी के, ब्रेन, लंग्स एंड हार्ट, तो सबसे पहले कौन काम करना बंद करेगा और सबसे अंत में सबसे अंत तक कौन काम करता रहेगा? एनी गेसेस? जैसे ही हम इसका आंसर है, जैसे ही हम सांस लेना बंद करते हैं, मतलब जैसे ही हमारा लंग्स काम करना बंद करता है, तो हमारे हार्ट में ऑक्सीजनेटेड ब्लड की कमी हो जाती है, जिसके कारण हमारे टिश्यूज में ऑक्सीजनेटेड ब्लड नहीं पहुंच पाता है। तो सबसे पहले हमारा लंग्स काम करना बंद करते हैं, जिसके कारण हम ब्रीदिंग नहीं कर पाते हैं, और उसके बाद में फिर तब तक हमारा हार्ट पंप कर रहा है, कहीं ना कहीं ऑक्सीजनेटेड ब्लड, जो ऑक्सीजन की भरपूर मात्रा है इसमें, वो कम होते होते इस लेवल पे आ जाती है कि जिसमें ऑक्सीजन नहीं होता है, क्योंकि लंग्स काम करना बंद कर चुका है। उसके कुछ टाइम बाद में हमारा हार्ट काम करना बंद कर देता है। तो कुछ रिपोर्ट्स में ये भी बताया गया है कि जब ये दोनों ऑर्गन काम करना बंद कर देते हैं, तो उसके थोड़े टाइम तक हमारा ब्रेन कहीं ना कहीं सिग्नल भेजते रहता है, बट उसको बॉडी से रिस्पॉन्स नहीं मिलता है, लंग्स से, हार्ट से, फिर ब्रेन काम करना भी बंद कर देता है। इस तरह किसी की डेथ होती है नेचुरली। चलो अब हम बात करते हैं मलेरिया के बारे में, मलेरिया डिटेक्शन के बारे में, कैसे हम मलेरिया क्या होता है और उसको हम लैब में कैसे डिटेक्ट करते हैं।
Hello everyone, I am Omkar Indari, working under Dr. Hemchandra Jha in discipline of Bioscience and Biomedical Engineering, Indian Institute of Technology, Indore. I am here to present microscopy-based malaria diagnosis seminar on the occasion of National Science Day, and I'll also be demonstrating you some of the steps from this particular technique. So the content of presentation will be introduction to malaria, malaria life cycle, demonstration, the result of the process, and acknowledgement. So introduction, I'll start with the introduction that what exactly is malaria. Malaria is caused by a one-celled parasite called as Plasmodium. Now there are different species of this Plasmodium which are able to cause malaria, like P. falciparum, P. vivax, P. malariae, ovale, and noelce. Out of this, falciparum and vivax are widespread and are responsible for the disease in the wider areas or in the most of the areas in the world. So this particular parasite is transmitted through the female Anopheles mosquito. The symptoms of this disease include fevers, chills, sweating in cycle manner. Apart from that, there could be headache, muscle ache and tiredness. Sometimes nausea, vomiting and diarrhea may also occur. Now this malaria may cause anemia as well as jaundice, that is yellow coloring of skin due to the loss of red blood cells. This particular parasite, it infects the red blood cells. I'll explaining how it infects the red blood cell in the next slides. Now, what are the treatments to treat this disease? Now, there are variety of antimalarials which are available, like chloroquine, hydroxychloroquine, artemisinin, etc. But prior to treatment, the diagnosis is very important, because if the fever in the patient is not diagnosed properly, whether it is a malaria fever or just a flu-like fever, then there will be delay in diagnosis, and person may suffer the severe condition of this malaria. So there are different diagnostic technique. Microscopy is one of the gold standard method to diagnose the malaria. Apart from that, there are different molecular methods like rapid diagnostic kits, polymerase chain reaction technique, etc. But out of them, microscopy is the gold standard because its simplicity and widespread availability in different regions of the world. So this is the map showing where the malaria is generally transmitted throughout the world. As you can see, in African region, it is the most abundantly spread. Apart from that, in the region of India also, it is transmitted through mosquitoes. So looking to the scenario in India, the malaria is widely spread generally in regions of Odisha, Chhattisgarh, Jharkhand and Northeast, but it is also spread in the various other states, as you can see in its proportion in different colors. Then this is the Plasmodium life cycle. I'll start explaining it from here. This is the mosquito. This mosquito which has already taken an infected person's blood. If it bites another person, the mosquito releases parasite into the person's body. This parasite preliminarily takes shelter in the liver cells. In liver cells it divides. This is the transient state or intermediate stage. Plasmodium do not reside here for their entire life cycle. From the liver cells they grow, divide and burst and come into the bloodstream. In bloodstream, which is the asexual parasitic stage, it grows and reside into the RBC. In RBC, it take the nutrients and shelter, where it grows into the more cells and further infect more RBC. If not treated at this particular stage, it may cause the severe disease. As it lives inside the RBC, it is hard for immune cells of body to recognize the infected RBC and to tackle this particular infection. Now, if any other mosquito comes and take up this blood can enter inside the mosquito, where it completes its further sexual life cycle. That is fusion of gametocytes produced by this particular parasite. And now when this mosquito again will bite another person, it can transmit the disease. In this way the malaria get transmitted, and this is the malaria parasite, that is Plasmodium's life cycle. So it is very important to diagnose this particular infection at the earlier stage, and that's why the microscopy of the blood sample is done to judge or to observe this particular parasites present inside the red blood cells.
Hello everyone. Hello everyone. I am here to demonstrate you malaria diagnostic technique using microscopy. So for that we are preparing here the slide. From the blood sample, I am currently taking a blood. I am putting here blood and making a blood dot. Now by using another slide, I will just spread this blood and make a smear. So this is a blood smear. I'll allow this smear to dry. By using a chemical named methanol, I will just fix these cells. That is, I'll arrest the cells in the stage which they are. There will be no further change into the slide now. So I'll overlay this chemical for half minute. After fixing, I have decanted or discarded the chemical which has been overlaid onto the slide, and I allowed this slide to dry. Now on the slide where the blood smear is prepared, I am putting this blue color stain named as Giemsa stain. This stain will stain the parasite living inside the RBC into the blue color, and the RBC will remain reddish color, reddish to pinkish color. So I'll evenly spread this stain, and now our cells will get stained. After staining, we have discarded our stain and washed the slide with water, and now allow the slide to dry. Now this is the dried slide, and you can see the smear. We will observe the detail of this slide under the microscope. Under microscope, we will observe this under 1000x magnification. Thank you.
So these are the result of our staining. As you can see, there are many RBC in this blood. You are currently able to see only RBC in this particular image. Here you can observe the normal RBC, which are not having any nucleus present inside the cell. So they have not taken any nuclear stain inside them. But here these are parasitized RBC, which are infected with the parasite. And this blue color parasite you can observe growing inside the cell. These ring kind of structures are different parasite embedded in the single cell. These particular structures take the nutrients and grow in this kind of cell and further divides. As you can see in this particular cell, there are different blue dots, though there are many parasites inside this cell. Now as the cell has been completely filled and nutrients are totally taken up by the parasite, this cell will soon burst and new parasite will come out to infect this uninfected RBCs over here. So this is how the presence of parasite in RBCs. We acknowledge here Dr. Hemchandra Jha, Assistant Professor IIT Indore, then Dr. Abhijit Joshi, Assistant Professor IIT Indore, then Infection Bioengineering Group at IIT Indore, Mr. Sandeep Chaudhary, PhD Scholar in BSBA at IIT Indore, and IIT Indore for providing facilities and support. Thank you.
So this is a standard technique when we go to the lab, either private or government lab. So we go for our malaria test. So they will do the similar kind of test as explained by Omkar in the presentation. Now we will see the pesticide detection, that how we will detect the pesticide, presence of pesticides in our, how we will detect in our lab.
Science may set limits to knowledge, but should not set limits to imagination. Happy National Science Day students. Myself Vinay, working in Molecular Immunology Lab under guidance of Dr. Prashant Parthire. Today, I would like to present a seminar cum demonstration on the eve of National Science Day. I am going to perform how we can detect presence of pesticides by sensor developed in our lab. So let's know what is the need of pesticide, what is pesticide and why it is problematic. A pest organism that damages the crop. Here is a few images that shows how it affects the crop. Use of pesticides prevents the growth of these pests, but its overuse may cause serious problems to humans as well as other organisms. And these pesticides we are using from ages, and many ancient civilizations used these pesticides to protect their crops from insects. For example, ancient Sumerians used elemental sulfur to prevent their crops. But in 1939, first chemical pesticide, that was DDT, was discovered, and it was extremely effective and rapidly used as the insecticide in the world. But after 20 years, due to its effect on human safety, pesticide DDT was banned in 86 countries. Since it is preventing the growth of insects and other organisms, it also affects humans and other organisms. And nowadays, due to overuse of pesticides, these chemical substances remain on the surface of fruits and vegetables while we buy them. And these pesticide residue, when consumed, may lead to food poisoning, diarrhea, hormonal imbalance, and in long term may cause brain, kidney, heart, and cancer also. So, detection of pesticides in packed food, in water, and surface of the fruit is very crucial. And these pesticides used may remain in the environment for the long time. For example, if you are using these pesticides to prevent the growth of pests, and overuse may run off into the water and affect the organisms living in water, and some of the pesticides get vaporized in the environment, and when we inhale that air that is contaminated with these pesticides may affect our humans as well as other animals. So the need is, how can we prevent the overuse of pesticides? Since there are many pests which are also growing along with these pesticides, for our personal level, we can wash these vegetables and fruits with running tap water. That will help in washing out the pesticide residue. Seasonal fruits and vegetables should be preferred, since these crops are not based on use of that much of pesticides. And cold storage items should be prevented from use. And so let's see the demonstration how we can detect the pesticides through our biosensor. Thank you.
Now we will demonstrate how we can detect the presence of pesticides. We are having pipette, resistive box, and here we are having the parazole pesticide, and we are having our sensor. And we are having tube 1 which we will add no pesticides, and tube 2 which contains pesticides, and this is discard. Now we will add pesticides in tube number 2. Now we have added pesticides in the tube number 2. Now we will add our biosensor which we have developed in our lab and see the color change. Based on the color change, we will get to know that whether the pesticide is present or not. So we will add biosensor in both tube 1 and tube 2. After adding in both tube, we will incubate it at 50 degrees Celsius in water bath. At 50 degrees Celsius. Now we will incubate it for 10 minutes. Now we have incubated at 50 degrees Celsius for 10 minutes. Now we will see the change in color. The tube 2 which contains pesticide, we can see that it is a yellow color, and tube 1 which doesn't have any pesticide is transparent in color. This shows that pesticides 2 have tube 2 have pesticides. Thank you.
Thank you so much. Thank you so much, BSV and team department, and thank you so much, Mr. Sandeep Chaudhary, for hosting the smooth, valuable presentation on biology for kids. हमें पूरा विश्वास है कि आज के कार्यक्रम से आप विज्ञान व विज्ञान से जुड़ी प्रत्येक घटनाओं से और अधिक जुड़ गए होंगे। क्यों, कहाँ, कब और कैसे, यहीं से शुरुआत है विज्ञान की। क्यों, कहाँ, कब और कैसे, यहीं से शुरुआत है विज्ञान की। और ये प्रश्न बढ़ते ही जाएंगे जब हल जानने की इच्छा हो इंसान की। और जब आपके पास हल जानने की इच्छा होगी तो आप और अधिक वैज्ञानिक सोच की ओर बढ़ेंगे और अपने हर प्रश्नों का उत्तर पा सकेंगे। प्रोग्राम से जुड़े प्रिय छात्र छात्राओं, विज्ञान सिर्फ एक विषय मात्र नहीं है। इसे जानना चाहते हो तो इसे अपने जीवन में आत्मसात करना होगा।
Thank you so much, everyone, whoever is present here to attend this wonderful event. Science should be used for the betterment of the humanity. With this, I would like to invite Dr. Deepak Kumar Roy, Coordinator of Organizing Team for National Science Day, for vote of thanks. Sir, please come.
Good afternoon, all, and I hope everyone has a wonderful day or half a day of program. So it's the final duty for me for the vote of thanks. There are many people involved in this, so I will start with. It's an honor to have been asked to offer a vote of thanks on the occasion of the National Science Day celebration at our institute. On behalf of the organizing team, National Science Day 2021, I convey my hearty gratitude to our chief guest, Professor Nilesh Kumar Jain, Director IIT Indore, and the guest of honor, Professor Avinash Sonavane, Dean International Affairs and Outreach, for gracing this occasion and by the presence and encouraging words. Special thanks to Professor Anurag Sharma for accepting our invitation to deliver a talk on this occasion. And it has been our tribute to listen to Professor Anurag Sharma on optics, and I'm sure many young minds have started to look things on optics differently. I'm thankful to Dr. Rajesh Kumar and team from Physics Department for wonderfully explaining the physics in daily life. I'm thankful to Dr. Manonita Chakraborty and team from Astronomy and Astrophysics Department for showing what happens when a star dies and explodes, and what happens when we play with the solar system and its gravity. Dr. Shantanu Manna, Dr. Ashisha Kumar, and Dr. Vivekananda Maji made us and his team made us visualize the basic mathematical concepts using real mathematical models, and I'm hopeful that keenness of the students towards mathematics will be in rise after watching this program. From Biosciences and Biomedical Engineering Department, Dr. Avijit Joshi and Dr. Hemchandra Jha and their team have demonstrated how heart works and what will be the behavior of a healthy lung and how to detect pesticides in water will definitely teach us to be wiser towards our health and environment. Students from chemistry department have shown several beautiful experiments to explain the illusion, which is nothing but science behind it. We are thankful to the Dean, Associate Deans of International Affairs and Outreach in supporting us during our real need time. The main motive of organizing this event is to enhance the reach of this program to large section of school kids and inspire them. In this regard, I take the opportunity to sincerely thank the Rajya Shiksha Kendriya Bhopal, Government of MP, for supporting us, popularizing our event, and enhance the reach of this program to all the government schools of Madhya Pradesh. I must remark a proficient thanks, sense of gratefulness to our International Office Public Relations Liaison Officer, IT team, particularly Mr. Nitin, Mr. Praveen, and Mr. Yagandro, and others, for smooth conduct of the entire program. Finally, I take this occurrence to thank the entire volunteer team to make this event a memorable one for the school kids. And big thanks to all the students and teachers and whosoever is connected virtually with this program. With the hope that current pandemic situation will improve and we will meet again, hopefully in person in the campus of IITI Indore with some more science-based activities next year at the National Science Day on 28 February 2020. Thank you.
सर, आप सभी का हृदय की गहराइयों से हार्दिक धन्यवाद। कार्यक्रम का समापन करते हुए मैं कहना चाहूंगी, बस विषय मात्र नहीं, मैं हर घटित घटना का सार हूँ। ज्ञान विज्ञान हूँ मैं, तुम्हारे हर सवालों का जवाब हूँ। अगले बरस फिर आऊंगा मैं विज्ञान दिवस पर और जानूंगा कि आखिर में कितने बच्चों का सवाल है। तो हम फिर से नेक्स्ट ईयर विज्ञान दिवस पर मिलेंगे। इसी के साथ हम इस प्रोग्राम का समापन करते हैं। आप सभी का प्रोग्राम में बने रहने के लिए हार्दिक धन्यवाद।